deep beneath our feet, locked in ancient stone older than the dinosaurs. Scientists have uncovered something strange. Tiny spheres, made of rare metals, scattered across the globe, lie embedded in rocks more than 60 million years old. Their pattern mirrors what we see from modern nuclear explosions, but these are older than humanity itself, for generations. We believed we were the first species to split atoms, to build machines, to change the atmosphere of an entire world. But what if that's not true? What if Earth has seen others before us, civilizations advanced enough to leave a mark, but old enough that time has nearly wiped it away? Today, we begin a journey through deep time, through strange chemical signatures, through evidence that might rewrite our understanding of civilization itself. This is the Silurian hypothesis, not just a question about Earth's past, but a possibility that could change how we see our future. The Earth is quiet here, a soft hush beneath your feet. The sky stretches above, slow and silver, and the air feels still, as if the world is holding its breath just for a moment. You walk gently, your footsteps pressing into soil, leaves, and the long-settled remnants of lives that came before you. You can't see it, not yet, but something ancient stirs beneath you. Beneath your toes lie stories, not written in ink, but in layers of sediment, in grains of sand and silt pressed together over time. Every inch downward is a step backward, not just in distance, but in memory. The Earth, you begin to understand, is not just ground, it is a book made of stone. You kneel and press your palm to the dirt. It's warm from the sun, but cool just beneath the surface. Somewhere far below, deeper than any root could reach, are pages too heavy to turn. Yet they are there, hundreds, thousands, millions of them, compacted into slabs of forgotten time. Each layer a whisper, each whisper a secret. The topmost layer is familiar. It holds your cities, your plastic, your concrete, your breath. Exhaled carbon etched into the atmosphere. It holds your noise, your brilliance, your mistakes. But as you imagine sinking downward, you drift through other worlds entirely. Just below your layer lies the age of ice and mammoths. Further still, the time of dinosaurs, great reptiles whose bones became stone, whose shadows still stretch through your dreams. Beneath them, stranger things, seas with no fish, skies with little oxygen, continents unborn, and life not yet imagined. And yet, between some layers, there is silence. There are places in the rock where time seems to vanish, where no bones remain, no pollen, no shells, no charcoal, no tools. As if the world simply paused or forgot to remember. These are not just gaps in the fossil record, they are erasures, missing chapters, torn out pages. You wonder, what could erase a chapter from the book of Earth? Perhaps nothing at all. Perhaps time itself is careless, and soft things rot too quickly to leave a trace. Perhaps geology is more blind than selective. But still, the question hangs in the quiet like a mist. What if the record isn't just incomplete? What if it's been overwritten? You lie back in the grass, eyes closed, and feel the ground beneath you. It feels stable, permanent, but it isn't. Everything changes. Mountains rise and crumble. Oceans flood and drain. Forests burn and bloom. Time swells and folds and erases. If a civilization came before yours, one born of thought, technology, and transformation, what would remain? Would they leave behind their monuments? Or would their monuments dissolve, like sandcastles left too long in the tide? You picture a city, lights, towers, engines humming. Now let 100,000 years pass. Let the steel rust. Let the glass melt into grains. Let vines shatter concrete. Let rivers reroute and flood the avenues. Let the sky take back the rooftops. Would there be anything left to find? Not much. Not easily. In a world that recycles itself, permanence is rare. Even bones are borrowed. Even mountains forget. And yet, some things persist. A thin layer of metal dust, a spike in carbon, an unusual pattern of isotopes, a faint chemical echo of combustion. These are not cities, but they are stories. Not sentences, but symbols. Enough, perhaps, to whisper, someone was here. This is the heart of the Silurian hypothesis. The idea that your kind may not be the first to awaken, that Earth may have seen other thinkers, other makers, other creatures, who touched the planet with tools and changed its air with fire. You do not remember them. But then, why would you? If their time was millions of years ago, even tens of millions, would their memory survive? Even a coin buried for 1,000 years becomes unrecognizable. What then of a civilization swallowed by oceans and plate? Tectonics twisted by heat and pressure, shattered and buried by time. It wouldn't take long. In geological terms, even 10,000 years is a blink. The entire human industrial age, all your progress, your power plants, your satellites, would barely register as a footnote in Earth's 4.5 billion year story. If someone else came before, their chapter may have ended before yours even began. You drift deeper into this thought, deeper into the soil of memory. You imagine not humans, but something else. Not aliens, not monsters, but minds. Minds like yours, curious and capable, born from the earth, raised by evolution, evolved to think, to question, to build, and then to disappear. You wonder, could they have passed through the same thresholds you now approach? Could they have burned fuel, warmed the planet, reshaped the chemistry of air and sea? Could they have faced the same crossroads, adapt or vanish, and failed? You picture a world not ruined, but reset. A great silence after the storm, forests returning, oceans clearing, and all that remained of those who came before was buried under time's slow tide. Perhaps the evidence was there. Perhaps it still is, misread, misfiled, mistaken for nature. After all, your sciences are still young. Your vision of the past is painted with the colors of your present. The fossil record shows a sudden rise in oxygen, the great oxidation event that poisoned most early life, but made your existence possible. Could that have been entirely natural, or could it have been altered? There are patterns, strange ones, in how species appear, thrive and vanish, in how chemistry shifts and temperatures change. Some of it seems random, some of it seems guided, but by what? You breathe slowly now. Your thoughts stretch like roots into the earth. The wind rustles the grass beside you, and for a moment you imagine it is not wind, but a whisper. The past is vast, wider than your imagination, deeper than your records. And Earth is old enough to have seen many beginnings. You open your eyes to the sky, quiet, still, endless, and somewhere beneath you the planet continues to turn. Stones continue to settle, layers continue to build. The library of time writes on dot, and if there is a chapter missing, it may not be empty. You stand now beside a cliff face, not tall, not dramatic, but old. Its edges are rough and sun-warmed, worn by wind and quiet rain. Here the earth shows its insides, layer upon layer, pressed like pages in a book left open to time. You run your fingers across the bands of sediment, ochre, grey, brown, and pale. Each one is a moment, a memory, a story set in stone. The rocks do not speak, not in the way you do, but they remember. This cliff is a library, not one built by hands, but by pressure and patience. Strata form from rivers laying down silt, from winds scattering dust, from oceans rising and falling. Bit by bit, year by year, the world preserves itself in layers. Time becomes tangible, and life, when it's lucky, leaves its mark. Fossils are not just bones, they are echoes of breathing things. A leaf's delicate veins turned to stone, the curve of a shell, long vanished, pressed into clay, a ripple in mud that hardened and never smoothed. Moments captured by accident, by miracle, by the slow embrace of geology, but for every story told in rock, 100 more are missing. The fossil record is not a complete history. It is a puzzle missing more pieces than it holds. Species appear, suddenly, without warning. Whole lineages vanish without a trace. There are chapters that begin halfway through a sentence, and others that end mid-word. This is the mystery. Not that the record is silent, but that its silences are so strangely placed. There are long stretches of continuity, of slow, familiar change, then sudden leaps, explosions of form and function, life diversifying in bursts. It's as if evolution jumps, stutters, or begins anew, and no one knows exactly why. Scientists call them gaps. Preservation bias, they say. Soft-bodied creatures don't fossilize well. Changes in climate or chemistry can erase whole regions of biological memory. Even erosion, just the ordinary wash of rain and time, can strip a layer clean, and yet some gaps feel too clean, too neat, like whole pages carefully torn out rather than naturally worn. One such mystery lies in the Cambrian. For billions of years, life was simple, single-celled, microscopic, barely complex. Then, suddenly, 540 million years ago, the oceans bloom with complexity. Creatures with eyes, legs, shells, teeth. Where there was silence, there is now song. This moment is called the Cambrian explosion. And even now, no one fully understands. It was a result of new oxygen, new predators, a genetic leap. Or is it possible that something left no trail? When you look at the fossil record, you're not just seeing bones, you're seeing absence. The holes speak as loudly as the fossils, and in these spaces, imagination begins to stir. Not as fantasy, but as inquiry. Because if life is continuous, why does it sometimes feel interrupted? You walk deeper into this thought, following the stones. You imagine the earth as a storyteller with a torn manuscript, a tale once told, now scattered, stained and lost, and you are the reader, turning crumbling pages, trying to piece together the plot. Could something have been written here that we no longer understand? You remember, even human memory fades. Languages die, books burn, cities vanish beneath sand and sea. So why not earlier lives, earlier minds, lost far deeper in time? You close your eyes and picture a coastline long before. Yours, not modern, not ancient, but alien in a way only time can make it. Maybe a creature stood there, looking up at the same moon, wondering its own questions. Would it leave a fossil, a footprint, a fragment of its tools? Or would everything it knew be ground back into dust? The odds of preservation are impossibly small. A living thing must die in the right way, buried quickly, undisturbed. It must survive pressure, heat, chemical change. Then, millions of years later, it must be found by someone who understands what it is. What are the chances? You begin to feel how easy it would be for an entire world to vanish, not in fire, not in war, but in forgetfulness, buried, compacted, recycled by the living earth, and still. Earth keeps some things. In Greenland, there are rocks over 3.7 billion years old. Within them, tiny carbon signatures suggest life, ancient, microbial, persistent. No bones, no cities, just whispers in stone. Even subtle life can leave a mark. So what of industrial life? Technological life? Would it leave behind something? Louder, you recall the idea of technofossils, not bones, but evidence of technology. Carbon spikes, plastic particles, synthetic molecules, radioactive isotopes with no natural origin. These things may survive, not by design, but by nature's slowness to forget. But would we know what we were looking at? If you stumbled across a chemical signature millions of years old, something strange, something out of place, would you see it as technology or mistake it for nature? Perhaps you already have. The fossil record is not just bones in rocks. It is a conversation between the past and the present. And sometimes the conversation is one-sided. Sometimes the rock says something, and we don't yet know how to listen. You kneel again, placing your hand on the stone. It is warm with sunlight, cool with age. You imagine the lives it has touched, the things it has seen but not spoken. Maybe you're not reading the whole story, maybe no one can. But every time you turn your attention to it, every time you ask what lies beneath, you come a little closer to understanding, not just the story of what lived, but the possibility of what was forgotten. There is more than silence between the layers. There is pattern, there is timing, there is the sense of something just out of view, a missing piece, a skipped chapter, a voice you almost hear, and as the sky darkens above your quiet place, you find yourself wondering not only what the rocks remember, but what they are waiting to reveal. Some gaps in the record feel random, but others feel deliberate. If evolution flows like a river, why do some moments ripple while others crash like waves? Close your eyes and let yourself drift backward, past the forests and rivers, past the towering dinosaurs, past the first mammals curling in their burrows, past the great swamps that would become coal, past every footprint, every breath you've ever known. Go deeper still. The world begins to lose its shape. No grass, no trees, no birds in the sky. The air is thick, heavy with gases not meant for you. The sun feels dimmer. The oceans cover more of the land. The continents are gathering in strange positions, unfamiliar outlines on an ancient map. This is Earth, 500 million years ago. You float in that early sea, warm and shallow, teeming with possibilities, but not much life, not yet. Only the simplest things, soft, microscopic, invisible without help, things that drift, feed, divide, and vanish. This is how life begins, in whispers. Then something changes. Suddenly, life appears with eyes, with shells, with limbs, with teeth and armor, and symmetry. Bodies, no longer just blobs, but blueprints, heads and tails, mouths and motion. Some swim, some crawl, some burrow, some hunt. In the blink of a geological eye, the ocean becomes a kingdom. This moment, this grand unveiling, is called the Cambrian explosion. It happened around 540 million years ago, and it remains one of Earth's most astonishing mysteries, because for billions of years before this, life evolved slowly. One cell became two, became colonies, became complexity, but always in quiet increments. Then, within just a few million years, complexity explodes. Almost all the basic body plans that exist today, from insects to humans, emerge in this window of time, as if nature threw back a curtain, and behind it stood the cast of an entire play, fully formed. You wonder, where were the rehearsals? Where are the earlier versions of eyes, the halfway shelled creatures, the almost legs, the nearly jaws? Where is the struggle, the stumble, the draft before the masterpiece? The record is quiet. The steps between simplicity and this sudden complexity are faint or gone. Some paleontologists have tried to explain this gap. Perhaps soft-bodied creatures didn't fossilize well. Perhaps climate or chemistry changed, unlocking new evolutionary tools. Perhaps predators arose, pressuring prey to innovate. All these ideas hold weight. Nature, after all, is full of tipping points. A small change can ripple into transformation, but still, you feel something strange here, because it isn't just what's present, it's what's missing. The world left behind very few fossils, sparse microbial mats, a few simple organisms, ambiguous impressions in stone, and then an explosion, not gradual, not hesitant, bold, sudden, like light flicking on in a dark room. You let your mind wander gently into metaphor. What if, instead of an explosion, this was a reveal? What if the Cambrian is not the start of something, but the end of something hidden? Imagine you're watching a play. The stage is dark for a long time. You hear muffled sounds behind the curtain, movement, shuffling, maybe even voices. Then, in one sudden motion, the curtain rises, and the actors are already in place. You didn't see them enter, but they're there. What if life, in some more complex form, was already rehearsing behind that curtain? What if earlier life was not entirely simple, just unseen? Or what if something once flourished before the Cambrian and left no trace you recognize? This is not a conclusion, only a question, but questions matter. They invite patience. They invite listening. You dive again into the Cambrian sea. This time with attention. You see trilobites, armored like tanks, eyes sharp and crystal-lined. You see strange creatures called Opabenia, with 5 eyes and a grasping trunk. You see predators like Anomalocaris, slicing through the water with plates like blades, and you feel the presence of design, not in the divine sense, but in the evolutionary one. Adaptation, purpose. Every structure here solves a problem, and yet, the leap into this complexity still baffles. How did these eyes form so quickly? How did hard parts, shells, spines, plates, emerge almost all at once? The genes behind these traits must have been evolving for some time. But where are their earliest expressions? Perhaps they existed, in forms you cannot see, in creatures too soft, too small, too scattered. Perhaps DNA carried secrets forward even when bodies did not. Or perhaps the Earth shifted in a way that accelerated everything. Oxygen rising, ecosystems colliding, climates becoming unstable. Or perhaps you are only now starting to ask the right questions. The Cambrian explosion marks a moment of becoming, but it also marks a wall, a veil on one side, a world of invisible life, on the other, a world full of wonder, and between them, something you cannot fully explain. You feel the tension of that divide, not fear, but curiosity, because when a pattern changes suddenly, it often means something has happened just out of sight. You lie back in your thoughts, as if floating again above those ancient seas. You think about how thin the fossil record really is, how most of Earth's story has been erased or overwritten. Even stone is not eternal. Even records crumble. And you think, what if something lived that did not fossilize? What if something once walked, or swam, or crafted, or thought in that silent space before the Cambrian bloom? What if you've mistaken the silence for absence? Your breath slows, the room darkens, your body softens into sleep, but your mind drifts still, gently through the folds of deep time. If there was a civilization before this explosion, it would be gone by, now. But maybe, just maybe, it left behind a clue, not a bone, not a building, but a pattern, a shift, a curtain, drawn back a little too quickly. You sit at the edge of the curtain, wondering, was it simply lifted by chance, or was something or someone behind it? And if life once bloomed, then vanished, how easily might a civilization do the same? You lie still beneath the weight of thought above you. Stars glow silently. Below, the earth turns slowly in its sleep. Your world feels solid, roads paved, lights shining, buildings tall and proud. It's hard to imagine it could ever vanish, but it will, not all at once, not in fire or fury, though that's possible. More likely, the end will come slowly, gently, like pages of a book curling in dampness. Time doesn't need to hurry. It always gets what it wants. You picture a city, busy, glowing, alive, traffic flowing, voices rising, the hum of machines and minds in motion. Now, fast forward, let 1,000 years pass, the lights go out, the glass cracks, rain seeps into the walls, vines begin to climb, roots swell under pavement, concrete buckles, steel rusts, silence returns. 10,000 years. Forests reclaim. The grid, rivers meander through avenues. Foundations crumble. Only shadows remain. Impressions in soil where towers once stood. 100,000 years. Nothing visible. Maybe a strange alignment of stones beneath the earth. Maybe 1,000,000 years. Even that fades. If no one were here to see it, would anyone know a civilization once existed? This is the quiet question that trails the Silurian hypothesis. The idea that an industrial civilization could have risen long before humans achieved technology, altered the planet, and disappeared without a trace. The challenge is not imagining such a civilization, but recognizing it, if it ever existed, because time does not preserve cities. It does not hold tight to skyscrapers or satellites or songs. It buries, it melts, it folds. You consider your own world. Humanity has built so much, so fast. Highways, power plants, space stations. But how much of it would endure the passage of deep time? Plastic, perhaps scattered microparticles, embedded in sediment carbon, yes, layered into the atmosphere, traced in ice, etched in the breath of oceans. Maybe radioactive isotopes, ones that don't occur naturally, but linger in the crust like strange fingerprints. And yet, even those fade. Plastics decay, carbon diffuses, radiation weakens, cities vanish like smoke. It's humbling, isn't it? You think of all you've created. The art, the knowledge, the networks entire. systems of thought and exchange, gone in the blink of geologic time. Just another thin band in a rock somewhere, a page in a planetary journal written in dust. If your own world could vanish so easily, then what of others? What of the time before time, the eons before humans walked? Could another species have risen, discovered tools, tamed energy, built wonders, and then been erased? You picture them, not aliens, not science fiction, but earthborn, evolved, like you, maybe reptilian, maybe something now extinct, maybe something you've never imagined. They learn, they build, they burn fuel, they change the sky, but nothing lasts forever. Maybe their cities fall to climate, or asteroid, or war, or simply time. Whatever the end, it comes, and the earth, patient and wild, covers them with silence. You wonder, would you recognize their signature? Because that's what science now searches for. Not artifacts, but imprints. Not tools, but patterns. A sudden spike in carbon isotopes. A strange metal in unexpected places. Unusual warmth in the fossil record. A climate that shifted without volcanoes. Layers with missing nitrogen or too much phosphorus. The world keeps such clues, not in detail, but in shadows. You think again about the iridium layer, that narrow band of clay discovered by geologist Walter Alvarez in Italy, just a centimeter thick, and yet it told the story of the asteroid that killed the dinosaurs. Proof of catastrophe, written in stardust. So what stories might other layers hold? You drift into the idea that every rock is a page. Every page a possibility. But even pages fade, even libraries burn, and if a civilization were truly ancient, not just thousands, but millions of years old, would its story be legible at all? To answer this, you step outside the idea of archaeology and into something grander. Planetary memory. The Earth remembers, yes, but it also forgets. Mountains erode. Oceans rise and fall. Tectonic plates subduct and recycle the crust. What was once surface becomes mantle. What was known becomes molten. This is the great eraser. So, maybe you should stop looking for fossils and start looking for fingerprints. The kind that remain not in ruins, but in systems, in disequilibrium, in the strange fact that Earth's chemistry has, at times, made sudden, unnatural turns, like the great oxygenation event 2 billion years ago. Oxygen flooded the atmosphere, reshaping biology forever. It's credited to cyanobacteria, tiny organisms mastering photosynthesis. But could such a dramatic shift happen more than once? Could a civilization, one with technology, force such a planetary transition? The Anthropocene, your present moment, may be an answer. You are altering the Earth's climate. You are shifting the carbon cycle. You've spread plastics and metals and isotopes across the globe. You've dug deep and built high in millions of years. What will remain? Not your names, not your buildings, but maybe the mark of change. Maybe another species, one that evolves long after you, will find the same puzzles. They'll find anomalies, gaps, silences, and they'll ask the same questions you ask now. Did someone come before? You press your hand to the Earth, or imagine doing so. You feel its warmth, its gravity, its depth. Somewhere beneath your fingers is a billion-year archive. Closed tight dot, and somewhere inside that archive, maybe, are footprints you don't yet recognize, because not all civilizations leave behind stone monuments. Some leave altered atmospheres, Some leave molecules, some leave mysteries, and some, perhaps, leave nothing at all. But if you had vanished, and if someone were looking for you, what would they find? Plastic, carbon, a layer of metal spheres? Or would even those be gone, scattered, broken, eroded, mistaken? And then you remember something else, the fragility of memory. Not just in stone, but in mind. How many human civilizations have vanished? How many names lost to fire and flood? How many languages never decoded, scripts never read, cities never found? And those were recent. What hope have you of finding something that came and went 100 million years ago? Still, hope is not the same as certainty, and mystery is often a doorway. You breathe slowly now. Your thoughts settle like sediment, one layer atop another. You no longer ask, did they exist? You ask instead, if they did, how would I know? You open your senses. You imagine the world as signal, not object, but echo, somewhere. Maybe in the chemical quiet of a deep-sea core, or the fine grain of Martian dust, or the isotopic rhythm of ice layers. A whisper waits. It says, something was here, something came and changed this place. Something left, it's faint, but it's enough. Civilizations vanish like smoke, but the air remembers. If something once burned bright and vanished without a word, might the planet still carry its warmth? Could the chemistry of the world itself be the only monument left behind? Breathe in, breathe out. And now, imagine that you are not standing on the earth, but sinking gently into it, not with weight, but with wonder. You drift downward, through topsoil and roots, through silt and shells, past the bones of forgotten birds and the teeth of ancient whales, deeper still, through hardened layers of clay and stone, until you arrive at a seam, thin, dark, and quiet, a boundary not just between rocks, but between worlds. This is the line that divides the time of dinosaurs from all that came after. End of one chapter, the beginning of another. A global exhale held still in stone, and nestled within that seam, barely thicker than a fingernail, lies something extraordinary, iridium, a rare metal, silvery, dense, almost never found in Earth's crust. But here it rests pressed into clay across continents, appearing all at once, like a breath held for millions of years and then released. Where did it come from? The answer, the one we now accept, begins with fire. 65 million years ago, an asteroid the size of a mountain struck the Earth. It came screaming from the sky, faster than sound, brighter than the sun. It hit what is now the Yucatan Peninsula, and in an instant it changed everything. Shockwaves raced through the planet. Firestorms bloomed across forests. Dust and vapor filled the skies, blocking sunlight. The climate plunged into cold and dark. Photosynthesis faltered. Food chains collapsed. In the span of a geological heartbeat, nearly 3/4 of all species disappeared. The dinosaurs, magnificent, long-reigning, were gone, but the asteroid left something behind. It carried with it iridium, not made on Earth, but born in the hearts of dying stars. When it struck, that metal scattered. It settled into sediments across the globe, leaving a silent signature in stone. A thin, quiet record of a day when the world changed. This is how we know. Not from a crater, not from a fossil, but from a metal. You linger with that thought, a single element, telling a planetary story. Now you ask, what other stories might be told this way? If an asteroid can leave a fingerprint, could something else? Could a civilization? Not one you know, not this one, with satellites and concrete and digital memories, but another, one older, one vanished, one that left no statues, no language, no myths, only chemistry. You turn your attention again to iridium, because it is not the only anomaly. Earth's crust, like a diary, holds moments of strange composition. Places where certain isotopes spike, where carbon behaves unusually, where metal traces appear in amounts too precise to be accidental. Some of these can be explained: volcanoes, ocean cycles, shifting climates, but others make you wonder, what if one of these mysterious bands, thin and quiet, like the iridium layer, was not born in fire from space, but in fire from invention? What if it marks not a meteor, but a machine? You imagine a civilization not unlike your own. Perhaps it too learned to dig, to burn, to build. Perhaps it mined metals. Perhaps it changed the balance of the atmosphere. Perhaps, in time, it made a mistake, or simply reached its end, and then nothing. Time closed in. Rain and rock and root reclaimed the world. Bones turned to dust, buildings to sediment. But the chemistry, STAYEDA, spike in carbon, a whisper of plutonium, a trace of synthetic compounds no volcano could make. You lie back in your mind, floating through possibilities. No proof, not yet, but not impossibility either, because now you know how long a signal can linger, even if it's just a film of metal. Between layers of clay, you think of Walter Alvarez, the geologist who saw the iridium layer and asked a question no one had asked before, and you realize discovery begins not in stone, but in wonder, in daring to ask, why is this here? It is easy to look at the earth and see it as permanent, as final, but it is a book rewritten constantly, pages buried and rewritten again. And sometimes, between chapters, a line remains. Sometimes it glows. You breathe slowly. Let your thoughts settle like dust on that ancient layer. Imagine holding a fragment of rock in your hand, thin, grey, ordinary, but inside it, the memory of stars, the echo of catastrophe, a whisper across deep time. This is what geology offers, not just facts, but echoes, not just structures, but stories. And sometimes those stories ask more than they answer. What if not all anomalies are from asteroids? What if some come from hands? Could the Earth hold more than one signature? Could the iridium layer be just one of many, some natural, some not? Could you, one day, discover a new kind of layer, one with traces not from space, but from minds? You don't need bones to know a thing once lived. You don't need ruins to know something once rose. Sometimes, all you need is a pattern, a spike where there should be none, a silence where there should be sound, a metal that doesn't belong. That is what you search for now, not in deserts, not in tombs, but in ratios, in chemistry, in the memory of elements. Because memory is not just for minds. Planets remember too, and if the Earth can recall an asteroid's kiss, it might also remember a mind's mistake. You imagine running your fingers along the seams of the planet, as if reading Braille, every ridge a boundary, every dip a secret dot. In one of those ridges, maybe, just maybe, lies another iridium, but this one, not from a rock, from space, from a reactor, a fire, a world, from someone, not so different from you. If a single metal could hold the memory of the sky falling, What else might be waiting in the layers, not fallen from the stars, but placed there by the hands of something that once called this place home? You inhale, you exhale. Each breath is a gift to the sky, a whisper of carbon carried aloft. And as you breathe, you leave a trace, a ghost of gas that drifts and lingers. Imagine standing in a meadow at dawn, dew glistening on grass. You watch your breath form a mist, vanishing into the light. But what if that mist lasted forever? What if every inhale, every engine's roar wrote a line in Earth's invisible ledger? Our world is full of carbon ghosts. They drift in the air, dissolve in the water, bury themselves in ice and mud. They record the pulse of life and industry. Each molecule carries a story. You close your eyes and picture the planet breathing. A slow, rhythmic inhale as forests flourish. A gentle exhale as animals roam and decay. A different pattern when machines hum a faster, heavier breath, marked by rising warmth. Scientists call it the carbon cycle, nature's way of passing carbon around. Living things grow by capturing carbon from the air. They die and carbon returns to the soil. Volcanoes and weather, the ocean and rain, all work together in a vast, silent dance. Now, imagine a new step in that dance. A step led by technology. Fossil fuels burned, ancient carbon released, changing the beat of the cycle. In that change, the planet pauses and listens. This is the Anthropocene signature, a pattern in ice cores, a spike in atmospheric records, a ghost that will linger for millennia. It tells future worlds. Someone here burned coal and oil, someone harnessed fire on a global scale. But could another also have done this? Not in the last 2 centuries, but in the depths of time. Could be. An earlier hand have stoked similar fires? Could ancient machines have whispered their own chemical clues? You drift through possibility. In your mind's eye you see a different world, one lit by fires whose smoke you cannot see, one warmed by engines whose roar has long faded, yet the planet remembers. Rocks hold records of this memory. Every layer of sediment is a page in a book. Some pages are black with soot, others show pollen flourishing after warming. Some carry exotic molecules, markers of change that no natural process can explain. You walk along a riverbank, fingers brushing smooth stones. Beneath your touch lies ancient data, microscopic shells of plankton, bits of charcoal, isotopic ratios that tell of warmth and cold, of feast and famine. Scientists study these clues like detectives. They drill deep into ice, extract cores that preserve seasons. They sift ocean mud, finding layers that correspond to climate shifts. They measure tiny variations in carbon-13 and carbon-12, searching for anomalies. And they have found them, brief pulses of carbon release, far beyond volcanic output. Sudden warmings in the Paleocene thermal maximum, 55 million years ago, when oceans warmed by 5 degrees in just a few thousand years. A brief twilight, followed by a return to normal dot. Could that have been nature's doing alone? Or might it hide a chemical whisper from a vanished industry? You picture a world awash in greenhouse gases, fogs of methane drifting over shallow seas, skies tinted by aerosols engineered to cool or warm, oceans acidified, life shifting in response. Then silence, then recovery. These are the pulses of planetary emotion, echoes in the carbon cycle, some caused by volcanic splendor, others still unexplained, like footprints in a dream. You breathe deeply again. The meadow returns. Wind stirs the grass. Your own breath is a gentle plume. You feel connected to this cycle, part of a vast living memory. How would you detect another civilization's breath? Not by monuments or bones, but by chemistry, by patterns in carbon, nitrogen, and oxygen, by subtle shifts, in isotopes that only a mind can decode. Imagine a future geologist centuries hence. They drill into ancient permafrost, examine ice from an age you cannot see. They find a layer where carbon dioxide spikes unnaturally high. They trace it to a century of warming too swift, too coordinated to be natural. They ask, what happened? Here, who was responsible? Now imagine that spike is not your doing, but someone else's, someone from deep in Earth's memory, long before you. You feel the weight of that thought, gentle but insistent, a question that stirs like wind in leaves. Could we be witness to more than one burst of chemical change? Your mind drifts to other chemical clues, bromine compounds that decay slowly, chlorofluorocarbons that freeze in ice cores, synthetic molecules that no bacteria know how to break down. What if, deep in a forgotten layer, a savvy mind engineered compounds to stay alive in the ground? What if the planet now holds a puzzle piece that doesn't belong to any natural cycle? You stand by the river's edge, watching water flow. Each drop carries carbon, oxygen, history. The river does not judge. It records what you feed it: leaf, littens, soil, pollutants, your own breath. Everything mixes, everything moves, and some of it settles into muddy pages that time will preserve in silent devotion. You kneel and run your fingers through wet mud. Tiny shells crunch between your fingers, organic layers hiding beneath mineral dust. These are the details of Earth's diary, a diary you're learning to read by chemical handwriting. And handwriting can be forged, it can be altered, it can belong to someone you never met. The river flows, and you see how easy it is to be carried away. Cars, factories, fires, your world writes its signature in carbon. In the same way, another world might have written its own. You breathe in and imagine the ghost of that world, a civilization whose chemical fingerprint lingered in the air, the sea, the ice. Its machines hummed, its fires burned, its tale told in molecules. But those molecules return to Earth. They dissolve or freeze or bury themselves in rock. Eventually, they settle, layer by layer, waiting for a future hand to uncover them. You stand and brush the mud from your fingers. The river continues its journey to the sea. So does the carbon. So does the memory. You realize that chemical clues are fragile and vast, tiny fingerprints across endless archives. They ask careful eyes and patient minds to decode them. They ask you to listen, to wonder. You close your eyes once more. Feel the breath of Earth around you, slow, deep, rhythmic. Your breath joins that rhythm. You are part of the cycle of carbon and curiosity, and as the day wanes, you let the thought settle. If a civilization wrote its story in molecules, could you learn to read its verse? The river of carbon flows ever onward, carrying whispers of life and industry. And beyond chemical ghosts lies another mystery, the energy that fuels those cycles. You close your eyes and imagine the Earth as a living thing, not soft or furry, but vibrant, a giant engine humming quietly in space. It drinks sunlight, breathes heat, and exhales wind and weather. This is thermodynamics, the poetry of energy in motion. Every day, the sun sends photons to Earth's Surface. These particles carry warmth, light, and life's potential. Green leaves unfurl to capture each one, converting it into sugar, growth, breath. Rivers carry heat from equator to pole, clouds carry water, and air itself moves in giant cycles. This flow of energy is the planet's pulse. Without it, the world falls silent, a cold husk adrift in the void. But with it, complexity blooms, storms, mountains, forests, creatures. Life is a master of thermodynamics, a process that gathers energy, transforms it, and returns entropy to the environment. You picture cells as tiny power plants. Each one ferries electrons, splits water, and builds molecules. They work together, in forests and reefs, in soils and skies. They stitch sunlight into sugar and carbon, weaving a tapestry of energy across the globe. This tapestry is not static. It hums and shifts, from dawn's first light to midnight's hush. It responds to seasons, to volcanic eruptions, to ice ages. And now it responds to you. Civilization is life's grand experiment in harnessing energy. You dig deep, pull fossil, sunlight from ancient plants, burn it in engines and furnaces. You spin turbines with wind and water. You capture photons with panels of glass. Each advance is a new instrument in the planetary orchestra. But what if this is not a human exception? What if harnessing energy at global scale is a natural stage in a planet's life story? Planets, like creatures, may pass through phases, barren rocks to simple life, to colorful biospheres, to energy-intensive civilizations, and perhaps beyond. Take Venus and Mars, siblings of Earth, but on different paths. Venus drinks too much sunlight, runs a greenhouse so strong its surface glows with heat. Mars, smaller and colder, lost its atmosphere, its water frozen or gone. Neither developed the dance of life that Earth perfected, but on Earth energy flows. Nurtured complexity. Life found a way to use solar energy, to harness chemical gradients, to drive processes far from equilibrium. Equilibrium is death, a uniform state with no motion, no change. Living things thrive in disequilibrium, riding currents of energy to build order at small scales. Imagine a bathtub left to itself. Water stands still, warm one moment, cold the next, but no patterns emerge. Add a little flow, a pump, pushing water along, and suddenly currents form. The bathtub becomes a river, a channel, a system of organized motion. Planets are bathtubs. Life is the pump. Civilization is a larger pump, drawing on deeper sources. First, simple microbes pumped energy gently for billions of years. Then life pumped more. Then intelligent life, curious and bold, began a new phase of pumping. This phase shows in the planet's metrics. Carbon dioxide levels climb. The water cycle intensifies. Heat accumulates. You see it in shifting weather patterns, melting ice, changing coastlines. You see it in nightly lights, glowing cities marking patches of concentrated energy use, viewed from space. Earth's nightside shimmers with technology. It is a sign of thermodynamic complexity, a planetary skin aglow with human activity. It is beautiful, fragile, and fleeting. What will come next? Planets can host many experiments. Some may falter and collapse, returning to simpler states. Others may learn to stabilize, a sustainable civilization that pumps energy without burning its world. In astrobiology, scientists classify planets by their energy flows, from barren class 1 to hot class 2 to biotic class 3, to agency-driven Class 4 and beyond. Each step marks a new level of free energy generation, that usable work that transforms the world. If Earth has reached Class 4, what lies beyond? A Class 5, where civilization harmonizes with life cycles, where energy pumping enhances, not destroys. You feel the magnitude of this moment. On the cosmic scale, planets evolve slowly, but you are here now, in the heart of transformation. Your choices will tip the scales, either toward collapse or toward a new equilibrium in which technology is woven gently into the planet's thermodynamic fabric. You visualize a garden at dawn, dew sparkles on leaves, bees hum between flowers, sunlight filters through branches. It is calm and alive. It is complex, yet balanced. A glimpse of what a thermodynamically integrated civilization might look like. You think of your own life, the warmth of your body, the beat of your heart. You are an engine too, converting food into motion, converting motion into thought. You contribute to the planetary engine, part of the web of energy flows, not separate, but woven into the whole. Slowly, your awareness expands from self to world, from world to star. You realize that energy flows connect you not only to Earth, but to the sun, to cosmic cycles, to the birth and death of stars. And in that realization, curiosity arrives. If planets can host phases of intelligence, what patterns echo beyond your home? What cosmic current carries civilizations across the stars? What thermodynamic dance plays out on distant worlds? You open your senses, feeling the hum of energy in the air. Electric lights glow softly around you. Your breath warms the cool room. Your body, a warm engine, rests on the bed as you drift towards sleep. You carry the knowledge that life and civilization may be natural expressions of planetary thermodynamics, waves of complexity, riding on currents of energy. And if that is true, then Earth's story is a chapter in a grander tale, one that spans planets, stars, and perhaps entire galaxies. You welcome the thought, gentle and vast. As you drift toward dreaming, if life and technology are but phases in a planet's dance, then Earth is not alone. Beyond our skies lie silent worlds, waiting for their own rhythms to awaken. You tilt your thoughts upward, past cloud and night, into the dark openness where stars hang like patient embers. You feel a familiar question arrive. Is anyone else breathing, wondering, building right now? The silence feels vast, but silence can be deceptive. A forest dawn may sound still until you learn its languages. Perhaps the cosmos has languages you have not yet learned. You recall the equation often whispered in curious circles, the Drake framework, an attempt to number the numberless, to break the unknown into factors, stars born, planets formed, worlds that host life, life that becomes aware, minds that build tools, voices that send signals, and the time those voices last. Each term a gate, each gate a narrowing. Even generous guesses yield possibilities, and still the radio sky remains quiet to your ears. So you wonder if the problem is not abundance, but timing. Civilizations may flicker like fireflies, bright, brief, and locally brilliant, yet rarely overlapping. You imagine a meadow at dusk. Tens of thousands of lights blink, but few synchronize. From afar, it looks almost dark, though in any given moment, a dozen lights are alive. The galaxy may be like this, a field of unsynchronized awakenings. You breathe slowly and feel the fragility of the present moment. Humanity's era of radio, satellites, and spectral leakage spans barely a century, a fraction of a geological blink. If another species on a distant world broadcast for only 1,000 years, the odds of those windows aligning shrink to near nothing unless there are countless such worlds. Silence might simply be statistical loneliness. You consider distance as dilution. A thriving world orbiting a star 100 light-years away might have ended before your great-grandparents were born. Its last transmission, if any, still travels. A faint shell of organized electromagnetic ripples expanding through interstellar medium. If your detectors are not sensitive enough, or not tuned to the right band, the wave washes over unremarked, adding to a background you label noise. How many such shells have already passed through you in ignorance? Then you think of another silence, self-imposed, quiet. A civilization may learn to minimize waste emissions for efficiency. Communication migrates from loud broadcast to tight beams, fiber, quantum link signals that do not spill into space. The early noisy phase is short-lived. The long, mature phase is radio dark. You, listening for leakage, hear nothing and assume absence. Yet absence of noise is not absence of mind. You let your imagination drift to evolutionary timelines. Perhaps most biospheres never reach sustained intelligence. Selection favors stability over technological acceleration. Some worlds remain exuberant with life reefs, forests, luminous microbial mats, without ever producing abstract mathematics or metallurgical industry. They are successful, harmonious, silent. A galaxy can be rich in life and sparse in signaling. Then comes the sobering possibility many technological cultures might self-limit or collapse. Environmental overshoot, resource depletion, uncontrolled feedbacks, destabilizing energy use themes you recognize at home. If the lifespan of an energy civilization is short compared to cosmic time, the chance of concurrent overlap falls dramatically. The cosmos could be a graveyard of past bright phases, each leaving subtle geochemical footnotes on its planet carbon perturbations. Synthetic halos, isotopic oddities, while interstellar space keeps no obvious memorial. You feel the emotional gravity of that idea, but you soften it with perspective. The same reasoning that yields potential scarcity also opens a path. Survival may depend on transitioning from extractive chaos to thermodynamic balance. The silent galaxy might be filled not only with endings, but with graduations, worlds that learned to quiet their footprint, blending technology into biospheric flows until signatures became delicate, sustainable, and effectively invisible at interstellar distances. You picture Earth's current glow from orbit city necklaces, shipping lanes, auroral curtains. A future Earth might look dimmer in visible light, yet richer internally, energy harvested from sunlight and wind, with high efficiency, little waste heat, minimal leakage. To an external watcher, you would appear less active, not more, just as. A mature forest looks calmer than a clear-cut construction site, though its internal metabolism runs deep. You shift your attention from outbound to inbound strategies. If the galaxy's conversation is mostly quiet or whispered, perhaps you listen differently, not just for steady beacons, but for transient technosignature, short bursts, narrow-band anomalies, unnatural polarization, spectral lines of engineered molecules. Patience becomes technology. Time becomes telescope. Accumulated data becomes a map of possibility. You think of SETA as archaeology extended through light years. Excavation not of soil, but of signals buried in noise strata. Each dataset is a sediment layer, Algorithms become brushes. Patterns emerge where randomness should dominate. Even a single confirmed technosignature would rewrite the chapter you inhabit, filling the cosmic silence with context rather than companionship. You let a further thought unfold. Perhaps the galaxy is already not silent. Perhaps you are the grammar of natural astrophysical phenomena, pulsars, fast radio bursts, magnetar flares that once seemed artificial. Each time you decode one, you reduce the mystery inventory. Yet decoding natural wonders sharpens your discrimination, refining your capacity to notice the truly anomalous. The clearing of false positives is progress, not failure. Silence itself becomes data. Non-detections constrain the average broadcasting lifetime, the density of loud civilizations, the power they use. Constraints shape theories. The void is contour, not emptiness. Like dark space between stars makes constellations legible, the measured quiet makes any future signal meaningful. You recall that Earth's own technosignature is young. If someone looked for you 1,000,000 years ago, they would have seen only biogenic gases, oxygen, methane imbalance, a hint that metabolism sculpted the air. This biosignature, a lone chemical disequilibrium, may be the most common advertisement of life. Intelligent observers might first catalogue living worlds chemically, then infer which could host advanced activity. Long before direct contact, you rest in that layered view. Life, then complexity, then cognition, then industry, then sustainability. Each phase altering planetary spectra differently. Perhaps you are midway. Perhaps the cosmic silence is simply what the middle sounds like, between initial awakening and long-term integration. You feel no urgency, now only a widening sense of belonging to a process older and larger than your species. Looking outward, you simultaneously look inward. The fragility you perceive in others, hypothetical stories reflects the choices unfolding in your own. Silence becomes a mirror. A gentle humility arrives. You are early in your listening. Your instruments expand. Your algorithms learn. Your patience lengthens. Waiting is part of the method. Wonder is part of the instrumentation. Hope is part of calibration. You inhale against cool air drawn over ancient molecules, recycled countless times through lungs, leaves, oceans. You exhale, adding your own imperceptible contribution to atmospheric history. That breath links you biochemically to trilobites, two ferns, two future minds perhaps not yet formed. Continuity within silence. You imagine, finally, a distant observer watching Earth centuries from now. Spectral lines steady. Greenhouse gases stabilized. Waste heat balanced. They might debate natural or cultivated. Biosphere only or biosphere, plus quiet stewardship. Ambiguity remains, and ambiguity is permission for dialogue. You open your eyes, or the inner equivalent, and let the stars return to their remote stillness. Silence no longer feels like absence. It feels like possibility distributed in time, and a soft question rises. If the galaxy's voices are faint and staggered, what subtle archaeologies might reveal the earlier ones here at home in stone? In chemistry, in buried planetary chronicles, you have only begun to read. If the sky's quiet invites you to search outward, Earth's deep layers invite you to search inward for echoes of minds you never met, and signals not of light, but of altered stone. You sit with a small piece of plastic in your hand, weightless, almost smooth, brightly colored, shaped for convenience. It feels ordinary, disposable, forgettable. Yet in deep time, this humble fragment is a monument. You turn it slowly, feeling its quiet defiance of decay. Plastic begins as ancient sunlight. Plants captured photons, built themselves from air and water. Buried, compressed, transformed, they became oil and gas. You drill, refine, crack long hydrocarbon chains. Reassemble them into polymers molecules, linked like beads in patterns nature rarely makes on its own. Polymer, a word meaning many parts. Chains of carbon and hydrogen, sometimes chlorine. Oxygen, nitrogen. Each chain is strong, flexible, reluctant to surrender its bonds. That reluctance is useful to you. Durability, resilience, low cost. It is also what anchors plastic into timescales far beyond your intention. You look around Naurum, street, city, planet and notice plastic everywhere. Insulation in wires, fibers in clothes, film wrapped around food. Tiny spheres once used. In scrubs, invisible threads shed from synthetic fabrics in every wash. Tires are braiding imperceptibly, sending particles into air and rain. Your world is dusted with polymer snow. Wind lifts microplastics into the atmosphere. Rain carries them down onto fields, glaciers, distant mountaintops. Rivers funnel them to estuaries. Currents concentrate them into ocean gyres. Sunlight embrittles larger pieces. Waves grind them. Life ingests them. Fragmentation replaces disappearance. Smaller does not mean gone. You imagine the ocean flora slow, dark archive. Falling organic debris mingles with silt, with diatom shells, with volcanic ash. Now, also, with plastic fragments, translucent shards, colored flecks, synthetic fibers coiling between sand grains. They settle in quiet layers, forming a technogenic confetti. A future core sample will pierce these speckled bands like a needle. Through a woven code, sedimentologists speak of fascias, textures, laminations, inclusions. You add a new category in your mind, plastogenic lamina, a horizon where polymer abundance spikes, marking the Anthropocene onset. Perhaps just a few centimeters thick in a million-year stack, yet compositionally unmistakable. An engineered signature. Embedded among natural minerals, some plastics sink, ballasted by biofilms. Others float, traveling far before eventual descent. Some become plastiglomerate, natural rock fused with melted polymer, sand, shells, charcoal. On heated beaches or near fire pits, softened debris binds grains into composite clumps. These accidental artifacts harden, weather, and may lithify the earliest stones of a synthetic geology. Future petrography might catalogue their textures the way you classify sandstone, chert, or breccia. You breathe gently and consider degradation. UV light cleaves polymer chains at the surface. Oxidation roughens edges. Microbes attempt slow digestion. Rates differ. Polyethylene persistently inert. PET more susceptible under certain conditions. Yet in deep water, cold and dark, reactions slow nearly to stillness. Persistence extends toward spans that rival fossilization processes. Imagine a future scientist, perhaps not human. They retrieve a core from an ancient seabed now uplifted into plains. They mount a thin section, sweep it with polarized light, scan its chemistry. They find concentrated carbon-rich flakes without crystalline order, consistent with ranges. Uniform pigments. Statistical regularity shouts intention. Manufacturing leaves pattern where nature favors variation. They test isotopic ratios of embedded carbon. Fossil hydrocarbons carry a light signature depleted in carbon-13 relative. 2. Inorganic sources. In the Anthropocene layer, this signature couples with synthetic pigment molecules, tholocyane blues, azo reds, titanium dioxide lattice whitened beyond natural abundance. The assemblage forms a fingerprint, petrochemical polymer plus engineered pigment plus heavy metal additive distribution. Interpretation becomes inevitable. An industrial epoch once blossomed briefly here. You touch your plastic fragment again. Its surface shows faint abrasions, micro scratches, mapping encounters with pockets, countertops, fingernails. These scratches are ephemeral at human scale, but could they persist long enough to speak of handling habits? Perhaps no. Perhaps the message distills not to microtexture but to composition. Abundance and abrupt onset. Abrupt onset. A key concept. For hundreds of millions of years, sediment contains none of this class of polymer. Then within decades global distribution. A step function rather than a slope. Geology rarely produces such instantaneous, planet-wide introductions without an external impulse. You recall other abrupt signals. Iridium at the dinosaur boundary. Sulfur spikes from massive eruptions. Black shales from ocean anoxia. Plastic differs. It is not a byproduct of a singular catastrophe, but of sustained activity. A diffuse chronic signal rather than a pulse. Its stratigraphic expression is cumulative, thickening with every shipment, every discarded film, every fiber shed invisibly in laundry water. Invisible does not mean intangible. Microplastics have entered plankton, mussels, fish, gut passages, tissue interactions, uncertain long-term effects, still studied, still nuanced. But beyond biological impacts lies the quiet geological inevitability, incorporation into the sedimentary record. You are, in effect, seeding future rock. You let the realization soften into wonder rather than guilt. Awareness opens the possibility of choice. If plastic is a stratigraphic letter you write to the future, what do you want it to say? Excess, carelessness, ingenuity followed by restraint. The lithosphere will archive only the outcome you imagine. Alternative future layers. Bioplastics engineered to mineralize rapidly, leaving minimal trace. Circular economies drastically reducing polymer throughput. Biodegradable composites whose residues blend indistinguishably with natural organics. In that scenario, the plastic spike narrows, its tail trimmed by remediation. Future interpreters might read it as a short, corrective pulse in adolescence, not a terminal condition. Now you widen your lens to include metal alloys, fly ash, spherules, synthetic nitrogen compounds bound in soils. Plastic is part of a broader technofossil assemblage. Each component reinforces the others. Coincidence of plastics, elevated nitrates, soot, radionuclides, altered pollen, spectra. Multivariate convergence reduces ambiguity. Randomness dissolves into narrative certainty. You think of artifacts erased by subduction, continental margins one day drawn down, metamorphosed, melted. Oceanic crust cycles every couple of 100 million years. Much will be lost. But continental basins, lacustrine deposits, polar ice for a while and soon shelf. Sediments may preserve enough. Sufficiency does not require completeness. Fragments suffice to infer wholes. You place the fragment down and close your eyes. You trace, mentally, the journey from monomer feedstock to manufacturing pellet to molded form to discard to fragmentation to burial. Each phase is a transfer across energy and material gradients. Thermodynamics at ordered polymer, created at energetic cost, dispersing gradually toward entropy, slowed by kinetic barriers. Plastic's persistence is delayed entropy, a plateau in the downhill run. Delayed entropy becomes information storage, not purposeful data encoding, yet signal nonetheless. Concentration patterns, particle size distributions, additive chemistry collectively encode production methods, economic scales, technological proficiency. In that sense, a landfill cross-section is a cultural spectrogram, a frozen chord of societal consumption. Landfills themselves may become future fossil reefs of technogenic material. Geomembranes, compaction layers, leachate pipes, mineralized plastic, compressed with organics into laminated masses. Anaerobic zones, slow decay, methane escapes. Eventually the structure is capped and vegetated. Over millennia, erosion may expose cross-bedded strata of refuse. Each holiday season or regulatory shift expressed in color bands of polymer prevalence. You breathe deeper now, gently aligning your own pace with the slow burial you envision. You feel both tenderness and responsibility. Tenderness for a species improvising with new materials. Responsibility for steering their legacy. Will a future mind one day hold a plastiglomerate pebble and feel the same? Mixture, you feel now curiosity or caution. Will they reconstruct your energy systems, your trade routes, your dietary shifts from polymer types and dispersal geographies? Perhaps they will even debate the moment awareness blossomed, the inflection where mitigation began. To thin the plastic curve. Awareness is itself a stratigraphic event, intangible yet influential. A cultural shift today alters tomorrow's sediment. Intent becomes geology. You open your eyes and release the plastic piece into a recycling bin or, perhaps a pocket, resolved to reduce disposables. The act is small, almost vanishing, yet cumulative. Small acts sculpt the eventual thickness of the plastic horizon. The night air is still. Somewhere far at sea, a fragment settles through twilight water, turning slowly like a falling leaf, coming to rest upon a thin dusting of diatom shells. Above it, waves whisper. Below it, bacteria dream in cold darkness. The fragment waits, patient, becoming part of a layer that will harden, tilt, uplift. You breathe again and hold the question gently. If plastic is the clearest line, you etch. Into deep time, what other signature subtler, more harmonious might you choose to add beside it? Beneath the bright colors and stubborn chains, another layer gathers metal traces, scattered rare elements, quiet isotopes, the metallic murmurs of industry waiting to be weighed. You rest your attention on a single atom, imagined as a tiny poised clock. Its nucleus quivers with stored possibility. Most atoms endure almost forever, patient scaffolds of matter. Some decayingly altering identity, ticking forward in imperceptible steps. A few split violently when nudged, releasing bursts of energy and fragments that will themselves continue the whispering lineage of change. You breathe and let the word half-life glide through your mind. Half-life is not an ending. It is a rhythm, the time in which half a population of identical unstable atoms will transmute. No individual nucleus follows a schedule. Statistics is the scripture. Probability is the pulse. Measure enough atoms, and the curve becomes smooth, graceful, predictable. Civilization learned this curve and turned it into design. You mined uranium ores, concentrated fissile fractions, arranged geometry so that neutrons born in fission would find new nuclei before escaping. You moderated them with water or graphite, slowed them, guided them. A self-sustaining chain formed, a controlled fire without flame. In that fire, binding energy-latent glue of protons and neutrons, and wound into heat, into steam, into spinning. Turbines, into lights, into quiet nighttime reading, into this reflective breath, splitting leaves, signatures. Fission fragments are shards of the nuclear table, isotopes of cesium, strontium, iodine, xenon, krypton, neodymium. They appear in ratios distinct from volcanic degassing or cosmic spallation. Neutron capture paints additional nuances. Activation. Products in steel, cobalt turning to cobalt-60, trace europium shifting, gold lattice whispering new gamma lines. Each product begins its own half-life descent, a cascade of decays stepping down through daughter nuclides, until stability is finally reached. You imagine a future. Geochemist analyzing clay from a horizon corresponding to your present century. They dissolve a shaving of mineral. They run it through mass spectrometry. They detect excesses plutonium isotopes with no natural origin other than rare deep-time supernova dust. Americium formed from plutonium decay, curium perhaps faint. Technetium traces, if any, remain bound in insoluble phases. The ratio of plutonium-239 to plutonium-242, plutonium-244 becomes a narrative reactor grade. Weapons testing, fallout geometry, atmospheric circulation. A pattern emerges impossible to attribute to lightning or magma. You think of atmospheric. Tests last century, brief artificial stars blossoming above atolls and deserts. Fireballs created fast neutron fluxes that forged radionuclides and lofted them into global winds. Stratospheric mixing settled them out over years, dusting soils, ice, sediments with a thin worldwide film, isochron of human intensity. Glaciers, trapped bubbles of air. Peatlands absorbed fallout. Deep ocean pelagic clays incorporated microscopic hot particles of fused glass and metal. These particles are durable, angular, compositionally exotic silica mingled with refractory metals, sometimes containing encapsulated inclusions. Barium, uranium daughter ratios out of equilibrium. Natural processes also write nuclear stories, and you weigh them carefully. Lightning produces fleeting radionuclides. Cosmic rays strike nitrogen and oxygen, forming carbon-14 and beryllium tangential. Steady scribes of atmospheric history. Granites host uranium chains. Monazite sands shine softly with thorium decay. 2 billion years ago at Oklo, in what is now Gabon. A natural reactor flickered when groundwater moderated rich uranium or its fission products, neodymium, isotopic shifts, and depleted uranium-235 fraction remain a unique geochemical signature. Proof that under special conditions, nuclear criticality can arise without culture. So you ask, with measured humility, could there be other Oklo-like anomalies not yet recognized or misinterpreted, bearing ratios inconsistent with natural moderation geometries? A prior industry, if it existed deep in time, might leave segregated zones of altered isotopic patterns. Localized depletion of uranium-235, coupled with specific distributions of samarium or neodymium isotopes, technogenic alloys fused with zircon grains, altered xenon isotopic anomalies trapped in crystal matrices. Over tens of millions of years, many short-lived isotopes vanish, but stable daughters remain arranged in branching proportions that still encode the vanished seed. You picture the decay chain as a genealogical tree carved into stone. even when the ancestors are gone, the descendants' arrangement hints at lineage. Excess lead isotopes 206, 207 can record uranium histories. Excess helium can betray alpha decay. But an industrial pulse might leave relative daughter inconsistent with slow geological accumulation, compressed time, volumetrically expressed. Detecting that requires exquisite precision, comparing multiple isotope systems, normalizing to unaffected control horizons. You roll the phrase stratigraphic anomaly across your mind like a smooth pebble. An anomaly is not yet evidence. It is an invitation. Science leans in, tests alternative explanations, volcanism, impact, diagenesis, fluid flow, metamorphism. Only after exclusions remain does anthropogenic or prior technogenic causation become plausible. Absence of artifacts does not nullify chemical patterning. Yet extraordinary interpretations still demand converging lines. Isotopic, mineralogical, sedimentological, temporal. Half-lives become temporal filters, sharpening or blurring signatures. Short-lived isotopes, iodine 131, xenon 133, vanish in weeks. Their memory survives only as secondary daughter enrichment or trapped noble gas anomalies sealed early. Intermediate ones, cesium 130, Sechi, strontium 90 trays, decades, 2 centuries sufficient, into annually laminated lake sediments, into coral bands. Long-lived ones, plutonium 239, uranium series, disequilibria, serve as durable parentheses enclosing the event. Very long-lived isotopes fade into normal crustal backgrounds unless concentrated or associated with distinctive matrices. You feel the subtle tension between signal preservation and geologic recycling. Weathering dilutes, groundwater mobilizes. Metamorphism resets mineral systems. Subduction erases entire provinces. Continents, however, retain ancient shields. Sedimentary basins stack history. Low-grade diagenesis can preserve delicate proxies. If a prior nuclear era were extremely ancient, most direct radionuclides would be gone. Yet unnatural elemental associations, molybdenum with unusual ruthenium ratios, clustered rare earth fractionation aligned with metallic spherules containing tungsten cobalt, alloys might persist. You rest your palm on a tabletop and imagine it transposed into the far future. Perhaps only trace chromium plating diffuses into clay. Nickel microfaces oxidize. Stainless steel transforms but retains alloy-specific chromium tunicle proportions uncommon in natural ultramafic contexts. Add neutron activation products, and the ensemble becomes unnatural, even when no original object survives intact. Detection becomes an exercise in multivariate pattern recognition. You see, in your mind, plots of isotope ratios versus depth, smooth background curves punctuated by a narrow excursion. Overlay other proxy carbon spikes, microplastic horizons, pollen turnover, fly ash microspheres, spheroidal aluminosilicate particles. Coincidence enhances attribution. One line is a curiosity. Several aligned is a signature. You exhale slowly. Awareness of your present imprint deepens responsibility. The quiet stewardship you considered earlier includes managing long-lived nuclear waste, sequestering radionuclides in engineered repositories stable against groundwater infiltration, seismicity, human curiosity, and glacial cycles. You imagine deep crystalline rock, bentonite swelling clay, copper or steel canisters, geochemical buffers. Will future beings read these repositories as cautionary monuments or as cryptic mineral bodies? Communication across millennia is a paradox. You cannot rely on language continuity, symbols drift. So you consider physical deterrence, remote placement, uninteresting surface expression, engineered benign alteration. Yet concealment risks accidental intrusion. Warning structures might attract attention. The design problem blends psychology with geology and thermodynamics in interdisciplinary meditation on humility. You contemplate timescales. 10 half-lives reduce activity by roughly 1,000-fold. Repositories are designed for spans exceeding cultural memory. Thus, nuclear stewardship becomes an ethical bridge from present decisions to unborn sensibilities. Your choices now sculpt the isotopic backdrop those minds will measure. You are already in dialogue with future analysts you will never meet. Could you, likewise, be the recipient of ancient dialogue without recognizing it? You revisit unexplained xenon isotope ratios in certain mantle-derived samples, odd helium distributions, rare fission track annealing patterns. Natural explanations remain strong. Still, you allow a narrow chamber in imagination where alternative histories breathe, not as conclusions, but as catalysts sharpening methodological rigor. Awareness refines listening. By practicing how you would detect yourselves after forgetting yourselves, you expand tools to study deep past natural perturbations, massive methane releases, ocean anoxic events, plume volcanism. The Silurian hypothesis is not mere speculation. It is an analytical mirror focusing your capacity to interpret ambiguous geochemical irregularities. You feel calm now, no urgency to claim hidden civilizations, no need to dismiss wonder, just a balanced, patient curiosity. Radioactive echoes are teachers. They reveal energy mastery, risk, memory, impermanence, continuity. They remind you that even invisible processes leave durable traces, and that durability is both gift and obligation. You let a final image settle, a wafer-thin slice of rock under a future microscope, a constellation of mineral grains, and among them a tiny inclusion registering a once elevated resewer, whisper of controlled fission in a vanished era. The observer pauses, notes the anomaly, and writes a question mark in the margin. That punctuation, small, curved, open, becomes the enduring shape of inquiry, and you wonder, softly, whether another kind of signal, not nuclear, not synthetic, perhaps living, self-replicating, might ride alongside these isotopic shadows, waiting for more sensitive eyes. If atoms can hold the faint afterglow of vanished fires, what patterns might living molecules preserve, biological edits engineered? Strains, silent scaffolds, woven into genetic archives, still replicating today. You sit with the quiet idea that a planet is not a backdrop, but a participant. It receives sunlight, spins, exchanges heat, releases volcanic breaths, weathers its own mountains. Left alone, change is slow. Continents drift a fingernail's width. Each year sees advance and retreat like a sleeper's chest. Life accelerates some flows. Roots fracture rock. Microbes fix nitrogen. Coral builds limestone cathedrals. Then, one day, in deep timescales, a civilization appears, a biosphere, folding back on itself with intentional force. You imagine Earth before deliberate reshaping, rivers meandering freely, sediment wandering toward deltas unimpeded, methane, balanced by microbial sinks. Then you layer on agency, dams, arrest, silt, channeling power, Deforestation alters evapotranspiration, shifting rainfall's inland reach. Croplands brighten surface albedo. Cities concentrate heat and nightlight. Dredging redraws coastlines. Fertilizers amplify phytoplankton blooms, leaving oxygen-thin zones. These are not isolated actions. They interlock, forming feedbacks, some stabilizing, some amplifying. You breathe slowly, tracing how a single innovation cascades. Domestication concentrates energy locally, enabling surplus. Surplus supports specialization. Specialization spawns metallurgy, computation, global exchange. Each step enlarges the sphere of influence until planetary cycles feel the imprint. Carbon dioxide rises, ocean pH shifts, isotopic ratios lean lighter, wildfire seasons lengthen, pollen spectra in sediment tilt toward disturbance species. You sense not randomness, but a directed perturbation, a pulse in Earth's metabolic chart. Was it always like this, only now? You consider abrupt past episodes, the Great Oxidation 2 billion years ago, the rapid carbonate dissolution and warming of the Paleocene thermal maximum, sudden onset of anoxic black shales in Cretaceous seas, mid-Devonian forest expansion, enhancing weathering, end Permian cascades of carbon and sulfur perturbations. Each event shows acceleration, a geologic tempo faster than baseline. Natural drivers stand ready, mantle plumes injecting large igneous provinces baking organic sediments, orbital configurations resonating with climate thresholds, evolutionary inventions, oxygenic photosynthesis, lignin digestion altering atmospheric chemistry. Still, you allow a slender question. Could intentional agency ever have overlapped these bursts, hidden within broader natural envelopes? You acknowledge parsimony. Extraordinary claims require convergent anomalous synthetic molecules, fossil alloy distributions inexplicable, engineered isotopic arrays. None have been confirmed beyond modern layers. Yet examining Earth as if it might host self-modifying phases refines your diagnostics. Preparedness to detect guides, careful measurement baselines, sharpen, uncertainties narrow, biases surface, and are calmed. You learn to partition signals. Volcanic mercury versus industrial mercury. Wildfire, charcoal versus soot spheres from combustion engines. Biogenic methane clathrate release versus sustained anthropogenic emission trajectories. You picture Earth's energy flows as braided rivers. Solar input splits into reflection, heating, chemical work. Photosynthesis historically diverted a small portion to living order, exporting entropy as long-wave radiation. A technological phase augments harnessed free energy by orders of magnitude. Fossil, sunlight, wind arrays, photovoltaic lattice, falling water through turbines, nuclear fissions, compact furnace. Increased throughputs, reshape allocation, more energy toward mineral movement, structural fabrication, information processing. From space, waste heat and night luminescence become spectral hints. Atmospheric spectrorecord, emergent gases, nitrates, novel aromatics, surface microwave emissivity, changes where materials blanket soils. You muse on thresholds. When does adaptation become transformation? A keystone might be the capacity to reroute major planetary fluxes, sediment routing, nitrogen fixation, carbon burial or release, river timing, even global reflectivity through aerosol management. You already test some levers inadvertently. Others you contemplate actively: carbon dioxide removal, stratospheric sulfate injection, ocean alkalinity enhancement. Such interventions, if sustained and coordinated, would compose an unmistakable technosystem layer, engineered disequilibrium intentionally maintained. If intentionality becomes stable, Earth may transition from reactive biosphere to guided ecotechnosphere. Guidance could bend risk curves, buffering volcanic aerosols with adaptive agriculture networks, modulating methane spikes with targeted oxidation catalysts, stabilizing ice sheet edges through structural or ocean current manipulation. Maturity would mean restraint, aligning energy use with renewable flux limits, designing materials to depolymerize cleanly, closing elemental cycles so little accumulates as geologic discard. In stratigraphy, the resulting layer might be thinner than a brief, unsustainable surge, yet richer in complexity signals, nanopatterned mineral composites, informational polymers, isotopically tuned catalysts, diluted but traceable. You see the ethical dimension woven through geophysics. Transformation without stewardship risks overshoot, biosphere simplification, resilience erosion, cascade failure. Transformation with foresight might increase biospheric options, preserving wild complexity while supporting cultured niches. You stand, imaginatively, at the hinge between those futures. Your present emissions, material flows, and genetic edits script boundary conditions for centuries of adjustment. You tilt inward and ask, how would earlier guidance manifest if it existed? Perhaps in anomalously rapid mineral sequestration of carbon matching no known basaltic weathering rates, or in a temporally sharp reduction of climate sensitivity through reflective particulates lacking volcanic sulfur isotope signatures, or in layered microbial mats with engineered metabolic pathways fossilized as unusual lipid distributions. So far, natural explanations suffice. Still, the exercise disciplines curiosity, teaching you to distinguish internal system innovation, photosynthesis, inventing oxygen flux, from external agency, civilization, optimizing energy harnessing. Agency differs by intention and information. Layering, not solely by scale. You press a palm lightly against the ground and feel nothing but you know beneath lies an archive, pollen, soot, fly ash, microplastics, fertilizer-derived nitrogen, leaded gasoline legacies, radiogenic markers, shifting ratios of stable carbon. Future readers will pass this horizon, time-stamping the acceleration of agency, perhaps noting a deceleration if sustainable practices prevail. The shape of the curve-sharp spike and crash, plateau, tapered evolution will become narrative, moral, and caution all at once. A planet that changes itself through life alone is remarkable. A planet that becomes aware of its changing and begins to steer is rarer still. Self-awareness at planetary scale is a reflexive loop. Sensors spread, satellites, buoys, genomic surveillance. Data assimilates into models. Models inform policy. Policy adjusts flows. Flows re-enter sensor networks. This cybernetic weaving is the circulatory system of guided transformation. You are already threading it imperfectly, unevenly, but unmistakably. You soften your thoughts and let gratitude enter, for the capacity to notice, to measure, to revise. Humility tempers ambition. Imagination tempers fear. Evidence tempers speculation. You feel the quiet responsibility of a phase that could either burn brief and scar or endure and heal. Endurance would mean designing change that enriches background complexity rather than narrowing it, leaving soils deeper. Rivers freer within managed bounds, genomes diverse, atmosphere balanced, oceans buffered. You picture distant observers, mapping exoplanet spectra. They flag disequilibrium, oxygen with methane, then minor industrial gases, then a gentle settling into a stable, moderated chemistry. No runaway greenhouse, no abrupt collapse markers. They might infer this world moved through a transformative phase and attained a guided steady state. If they reach out, they will do so trusting that guidance correlates with ethical maturity. You return to your breath. Inhale, exhaler, microcycle. Nested in global oxygen turnover, itself nested in solar photon flux, nested in galactic orbital motion. Agency does not lift you outside natural law. It deepens your participation, adding layers of feedback. To change the planet is unavoidable. To change it wisely is a cultivated art. You let one final image settle. A future stratigraphic cross-section held by careful hands. At your horizon, a narrow band gleams with technogenic complexity. Then above it, more muted layers, signals of modulation, balance, continuity. A note is penciled in the margin, inflection onset of sustained stewardship. You wonder whether that annotation will be written, or whether the line will thicken into a spike of absence. The choice ripples outward quietly even now, and you feel the next question rising, about memory coded not only in rocks, metals, and isotopes, but in the living script carried cell to cell. If continents, oceans, and air can be guided, what subtle traces of guidance might already travel inside DNA edits? Borrowings, silent scaffolds, waiting for you to read them as a layered palimpsest of intention. You begin by picturing a dark sphere adrift in interstellar cold. No air, no water, no chemistry, cycling only silent minerals, radiating away the faint heat of formation. This is simplicity at the planetary scale, a world scarcely stirred beyond internal cooling. Astrobiologists call it, in one scheme, class Ian energetically basic planet. It absorbs starlight if it has a star, conducts heat inward, re-radiates infrared outward, and little more. Class I worlds are plentiful, cratered moons, airless asteroids, dwarf planets with thin eggs, sipped from ice or rock. Energy arrives almost untransformed, like rain falling on polished stone and flowing straight off. No thick atmosphere to convect, no oceans to circulate, no large gradients supporting complex weather. Entropy slides downhill with minimal detours into structure. These worlds remind you that order needs a scaffold. Without layers, gradients cannot nest. Now you add an atmosphere, perhaps a shallow ocean. Convection begins. Winds arise, clouds trace patterns, frost lines migrate with seasons. Day-night temperature contrasts soften. Latitudinal heat transport emerges. Weather sculpts, dunes, dust hazes, perhaps methane rain on a distant cold satellite. This is Class II, a world where abiotic physical processes multiply pathways for free energy flow. In Class II, sunlight is still the primary driver, but now it spins atmospheric Sells-Hadley-like circulations, jets, baroclinic, eddies, phase, changes of volatiles, water, methane, nitrogen store and release latent heat, amplifying complexity. Rivers of liquid water or hydrocarbons engrave branching networks, increasing interface area where gradients do work. Still, chemistry remains mostly near equilibrium at large scales. No global biological metabolism perturbs the air's composition dramatically. You think of Mars in its early wetter phase, or Titan's hydrocarbon cycles, dynamic yet unbreathing. In the biotic sense, then somewhere metabolism ignites, a self-propagating set of reactions uses gradients to build replicators, membranes, enzymes. These spread, diversify, and begin to alter surface chemistry, harvesting solar photons or chemical disequilibria at vents. With life comes a persistent, active maintenance of atmospheric imbalance. Oxygen traces appearing, methane trickling, or other redox couples sustained. The planet enters Class 3, a biosphere-modified world. In Class 3, free energy generation increases because biology intercepts part of the solar flux and channels it through metabolic networks. Cells act as microengines, pumping ions, fixing carbon, releasing byproducts that accumulate beyond what inorganic kinetics alone would permit. Sediments trap organic matter, modulating carbon cycles. Microbial mats sculpt mineral precipitation. Soils arise, boosting water retention, nutrient recycling, weathering rates. Cloud condensation, nuclei from biological emissions adjust albedo subtly. Feedback loops proliferate. Life cools or warms its world indirectly, reshaping niches that favor further adaptation. Oxygenic photosynthesis, when it evolves, is a planetary revolution, a new high-energy electron pathway, releasing O that oxidizes crustal minerals and allows energy-dense, aerobic respiration. The air drifts further from equilibrium. The spectral fingerprint of the planet changes. Simultaneous oxygen and reduced gases signal active metabolism. You recall present Earth still holding traces of this long Class 3 ascent. But something else has recently layered atop it: intentional, large-scale reallocation of energy. When a lineage evolves cognition capable of symbolic abstraction, cumulative culture, tool amplification, and ultimately industry, planetary free energy use can spike. Fossil carbon, ancient, buried photosynthetic work gets tapped in compressed geological instants. Metal cycles accelerate. Nitrogen fixation leaps from biological enzyme limits to industrial scales. Land cover reorganizes net primary productivity. Information networks coordinate extraction, distribution, innovation. This is Class 4, an agency-dominated biosphere, a technosphere intertwined with the living skin. Earth today fits between late Class 3 and emergent Class 4, a hybrid. Many flows remain biospheric. Photosynthetic primary production still outruns industrial energy. Yet human appropriation of net primary productivity, freshwater, and sediment routing is substantial. Fossil fuel burning releases carbon orders of magnitude faster than long-term weathering can resequester it. Synthetic nitrogen now rivals natural biological fixation, altering watershed chemistry and ester and oxygen budgets. Plastics, alloys, persistent organics, and radionuclides become stratigraphic markers. Planetary albedo edges modestly in urban regions. Aerosols perturb shortwave scattering. Intentionality broadens the spectrum of energy gradients. Exploited geothermal, nuclear fission, wind harvest, solar photovoltaics, capturing photons with efficiencies beyond leaf averages. Yet, Class 4 is unstable if unmanaged. Overshoot can degrade biosphere resilience, narrowing diversity, simplifying feedbacks, amplifying vulnerability. If extraction outruns regenerative cycles, the technosphere cannibalizes its foundation. Thus an inflection becomes possible. Either collapse or regression toward a leaner Class 3 state, or worse, or transition into a steadier phase where technological agency supports biospheric robustness rather than eroding it. That hypothetical mature phase, sometimes proposed as Class V, features intentional, sustainable co-regulation. In Class V, A civilization aligns its total energy throughput with renewable flux boundaries, stellar irradiance, sustainable geothermal flow, possibly fusion harnessed without unbalancing planetary heat distribution. Material cycles close, waste becomes feedstock. Polymer design encodes depolymerization pathways. Mining shifts largely to controlled recycling and modest asteroid inputs rather than constant lithospheric incision. Carbon drawdown technologies gently restore atmospheric balance without triggering unintended climatic overshoot. Biodiversity stewardship preserves redundancy, stabilizing ecosystem services. Information systems optimize efficiency, lowering dissipative leakage. Technosignatures may soften, fewer broad-spectrum radio leaks, minimized waste heat plumes. Engineered chemistries designed to biodegrade cleanly, making a Class V planet harder to detect externally by naive methods. Paradoxically, higher internal organization decreases outward loudness. From afar, a Class V world might resemble a well-regulated Class III, distinguished mainly by subtle spectral hints, perhaps controlled trace gas cycles, precisely moderated aerosol seasonalities, unusually low variance in certain climatic indices relative to orbital forcing. Internally, however, free energy use per unit biomass might be higher, but channeled with extraordinary efficiency, producing minimal unintended entropy export spikes. The planet's cybernetic layer sensors, models, adaptive governance, a nervous system guiding feedback adjustments. You map Earth's history through this ladder. Early Earth, Class II physical cycling, tipping into nascent Class III with microbial metabolisms in Archean seas. Major oxygenation events intensify Class III traits. Multicellularity, forests, reef systems expand complexity. Hominin cognition ignites late-phase biospheric rearrangement. The Industrial Revolution accelerates the class for ascent. The current century, a hinge region whose stratigraphic thickness may end up mere centimeters, yet whose consequences frame millions of years. Earth could plateau into Class V stewardship or retreat via diminished complexity if runaway feedbacks climate. Biogeochemical, geopolitical push systems past adaptive capacity. You notice the energetic lens reframes morality pragmatically. Good becomes configurations that maintain long-term high quality. Free energy pathways without destabilizing boundary conditions. Poor becomes those that front-load energy extraction while degrading gradient-generating infrastructures. Soils, pollination networks, climate stability, ocean alkalinity, ethics, ecology, thermodynamics converge. Planetary health is sustained disequilibrium managed elegantly. Enough gradient to power processes. Not so much unmanaged flux that subsystem collapse cascades upward. This classification is not destiny, but descriptiona scaffolding for questions. Could a planet skip directly from Class II to Class IV if life emerges late and intelligence evolves rapidly? Unlikely, because the foundational biogeochemical cycles that underpin technological complexity require long biospheric preconditioning, oxygenating crust, depositing accessible ores, sequestering fossil energy, enriching nutrient distributions. Could a Class IV world relapse to Class II? Possibly, if biosphere losses cascade beyond recovery thresholds, runaway greenhouse eliminating surface oceans, or severe impact sterilizing shallow life, leaving only minimal geochemical cycling. More plausibly, collapse would drop a world. From hybrid IV back to a simplified III, with reduced diversity and lower free energy capture. You examine feedback levers, enabling upward transition. Information density. More accurate models reduce overshoot. Cultural memory, longevity. Institutions preserving intergenerational learning dampen boom-bust cycles. Redundancy. Diversified energy portfolio decreases catastrophic risk. Rate moderation. Slowing exploitation lets feedback signals surface before thresholds are crossed. Biophysical restoration, rewilding, soil carbon buildup, wetland renewal re-expand biospheric buffering capacity. Conversely, levers of regression include exponential extraction, erosion of trust, dominance, externalization of waste, discounting of far future impacts, narrowing of adaptive horizon. Thus, classification can inform strategy. Aim for indicators that proxy movement towards sustainable agency, declining material, throughput per unit well-being, stable or rising biodiversity intactness, flattening atmospheric perturbation. Curves, increased closed-loop recycling ratios. Diffusion of decision-making grounded in transparent data. You feel how the lens dissolves a human-centered narrative, embedding humanity as a phase within a planetary thermodynamic storyline. This does not diminish meaning. It enlarges two decisions, modulate Earth's trajectory inside a universal pattern of gradient exploitation and potential maturation. The Silurian hypothesis becomes a methodological echo. If earlier Class 4 pulses had occurred, would their remnants be discernible now? By practicing detection criteria, you refine stewardship metrics for your own pulse. Imagine distant observers compiling a catalogue. Planetary system 3427 blue, transitioned to low variance atmospheric regulation. Trace anthropogenic gases present. Historically, current classification, stable Class V candidate. Your legacy, then, is not a spike of discarded artifacts, but a persistent complexity footprint integrated with biospheric resilience. If, instead, the catalogue reads, transient technosignature, abrupt carbon isotopic excursion, plastic polymer horizon, radionuclide, pulse followed by resplification, the story shrinks, a brief bloom fading. You breathe slowly, internalizing the quiet instruction. Movement along classes is not inevitable progression. It is conditional navigation. Evolving complexity without adaptive ethics yields brittleness. Coupling knowledge with humility yields longevity. The free energy a planet channels is finite in usable streams. Wisdom is arranging flows so that quality, distribution, and renewal cohere. You turn inward and notice your own metabolism mirroring planetary energetics, intake, transformation, regulated, dissipation. Personal choices propagate aggregate demand patterns, scaling to global flux redirection. Individual awareness alone is insufficient, yet awareness seeds cultural shifts. Culture seeds policy. Policy reshapes infrastructure. Infrastructure redefines default behaviors. Defaults steer aggregate energy trajectories. You let the classification names fade to background. What remains is a felt sense of Earth balancing at a contour between extraction-heavy adolescence and potential integrative adulthood. This contour is narrow. The vista beyond is wide. Your era's work is smoothing the path so future ages inherit. Gradients still rich for life's creativity. A soft curiosity rises. If worlds can cycle, can intelligence itself seed resilience, tools before crises, peak anticipatory rather than reactive? Such foresight would itself be a hallmark of Class V emergence. Proactive gradient design, conscious entropy budgeting, compassion entwined with calculus. You pause, gently, on the brink of rest, holding the layered image, barren stone, weathered, air, living film, industrious flair, integrated stewardship. A ladder, yes, but also a loop, reminding you that ascent requires renewing foundational layers continuously. Lose the microbial custodians, and the tower falters. Neglect soil and nutrient cycles thin. Ignore ocean plankton, and carbon pumps stall. Class V is not a tier above life. It is life amplified and protected by mindful agency. And as you lean toward sleep, one more question glows. If classing worlds by energy clarifies trajectories, what other metric, perhaps the coded library of genes themselves, might reveal the deep continuity between biosphere and mind? If planetary classes map the flow of free energy, genomes may map the layered memory of each transition. Mutations, symbioses, borrowed genes, quiet edits, a palimpsest of long ascent, awaiting your attentive reading. You begin by imagining a parchment reused many times, words written, scraped away, written again, faint older ink still shimmering underneath. That kind of layered manuscript is called a palimpsest. Now you turn inward and realize every cell of your body is a living palimpsest. DNA holds fresh sentences, proteins you build tonight and ghost. Sentences, sentient instructions carried forward across oceans of time. You are reading and being written at once. A genome is not a neat, single-author book. It is a collage. Some sentences date back to early bacteria-like ancestors. Some chapters emerge as whole organelles, joined like small books glued inside. A larger volume, mitochondria, the tiny powerhouses in almost all your cells, still whisper with their own little circular DNA, a mentioned partnership where one cell engulfed another and, instead of digesting it, formed a cooperative household. Later, plants did something parallel with chloroplasts, letting sunlight feed sugar into the shared ledger. These endosymbioses are like decisive edits that permanently changed the style of the text. Other alterations arrive as horizontal gifts. Viruses inserting code, mobile genetic elements copying and pasting themselves. These jumping genes, or transposable elements, are like repeated decorative motifs stamped again and again through the manuscripts, sometimes helpful, sometimes merely taking space, sometimes disruptive. Over millions of years, most lose activity, but their faded patterns remain, forming a background wallpaper you can still chemically trace. Mutation itself is gentle drift. Single letters swapped to point mutation, small lines added or lost insertions, deletions, paragraphs, duplicated gene duplication, whole pages rearranged inversions, translocations. At first glance, it looks messy, yet that seeming messiness is raw material. A duplicated gene can relax. One copy keeps the original job while the other experiments. Some experiments become new tools. Hemoglobin varieties for fetal life. Enzymes specializing in different temperatures. Odor receptors diversifying your scent map. Innovation leans on redundancy. You breathe slowly and imagine a molecular clock. Mutations accumulate at roughly average rates. By counting differences between sequences, you can estimate how long lineages have been diverging. It is like measuring the fading of shared ink. Not every section ticks evenly. Some regions mutate faster because they are less functionally constrained. Still, across enough letters, signal emerges. So you can time splits. When primates diverged, when humans and chimpanzees branched, when populations migrated. Timing emerges from patient comparison. Epigenetic marks are softer pencil notes layered atop the printed text. Chemical tags on DNA bases or on histone proteins around which DNA is wound can tighten or loosen axes, turning genes up, down, or off. These marks respond to environment, nutrition, stress, sleep, temperature. Most are rewritten with each generation, yet some patterns echo across at least a few. They form a dynamic whisper channel, context-based modulation rather than permanent revision. Ancient DNA studies extend reading backward, but preservation is fragile. Heat, moisture, oxygen enzymes break strands. Under permafrost, in dry caves, in deep cold sediment, fragments survive longer. Scientists rebuild partial sentences from splinters, aligning overlapping pieces like jigsaw edges. Even then, there is a horizon beyond certain ages. Chemical damage overwhelms legibility. That boundary is a practical limit on how far you can directly read. Beyond it, you infer from living genomes comparisons. If a technological civilization wanted to leave an almost unerasable message, could it hide it in genomes? A speculative thought, yet instructive. You consider criteria. The message must not harm fitness, or it would be purged, must look natural. Enough to avoid immediate deletion by DNA repair, must be redundantly embedded. Perhaps in synonymous codon choices or in repeat copy number ratios arranged into prime-length patterns. So far, no such unmistakable artificial signature has been found. Still, the exercise sharpens awareness. What patterns are expected from natural processes? What would look suspiciously rule-like? You think about junk DNA, a phrase, now softened. Much non-coding sequence is not protein blueprint, yet it can host regulatory switches, structural spacers, microRNAs, or simply ballast that modulates mutation dynamics. Even apparently neutral sequence can become raw material for future function. The palimpsest keeps more than it immediately needs, like an attic storing objects that might later be repurposed. Viruses act as relentless, marginal annotators. Retroviruses copy their RNA into DNA and paste into genomes. Some past viral insertions mutated into silence. Others were co-opted. A striking example: genes derived from ancient viral envelopes help form the placenta in mammals, enabling nutrient exchange between parent and developing fetus while managing immune boundaries. Viral legacy turned to architectural fabric. Adversary became apprentice. You trace your own developmental journey. A single fertilized cell divides, differentiates, tissues forming. Each cell carries the same core text, but reads a different subset. A neuron foregrounds signaling genes. A liver cell foregrounds metabolic pathways. This selective reading is like applying bookmarks and sticky notes, while the base letters remain shared. Organization, emerging from regulation more than from changing the letters each time. Horizontal gene transfer in microbes means genetic innovations can spread sideways, not only downward parent to child. A bacterium developing antibiotic resistance can pass the gene via a plasmid to a neighbor. That neighbor proliferates, altering community function. The gene behaves like a useful paragraph, detached and mailed to multiple distant libraries. In microbial mats, sewage treatment plants, soil aggregates, this exchange accelerates adaptation. Over very deep time, traces of such transfers accumulate, making ancestry a web rather than a simple branching tree. You exhale and realize that reading the palimpsest is also reading climate history. Ice age shifts, dietary changes, pathogen exposures leave population bottlenecks and expansions. Population genetics extracts these events from patterns of variation, like measuring spacing between similar ornaments repeated with drift. Declines tighten diversity, expansions broaden. Migrations leave admixture mosaics. These statistical imprints become a demographic echo of environmental shifts. Some sequences evolve under strong constraint. They change little. Ribosomal RNA across distant species retains core shape-enchant ink that simply will not scrape away because its structure is vital for life's translating machinery. Other regions are free-form scribble, rewriting rapidly. Together, conserved cores and variable fringes create an index, stable anchors for alignment, flexible zones for innovation. You consider CRISPR systems bacterial, adaptive, microbes cut foreign viral DNA and store snippets in arrays, then use them as guides to recognize future attackers. These arrays are chronological records, a molecular diary of past viral encounters. Each new spacer is a dated entry. In reading them, you reconstruct a history of microbial warfare. Life is writing threat logs into itself. Synthetic biology now gives you tools to write more deliberately, editing disease mutations, adding traits, resurrecting lost gene functions. Responsibility swells, because edits today can propagate. Ethical guidelines, containment practices, transparency, global equity in access will become part of stewardship, extending earlier chapters' themes. The palimpsest metaphor asks, which edits serve long-term resilience and which risk narrowing future possibility? You notice a paradox. The genome's meaning is not in letters alone, but in timing, context, folding, methylation, interaction networks. A static file analogy fails. A symphony score suits better notes recurrent, meaning shifting with tempo, instrumentation, dynamic markings. Your cells are conductors, continuously adjusting interpretation. The palimpsest includes not just overwritten ink, but marginal performance directions. Deep time erases a lot, but not pattern statistics. Even if every ancient individual strand was lost, frequency distributions and motif architectures persist. Studying those broad shapes can falsify wild claims. If someone proposed a prior engineered genome epoch, you would look for unnatural codon usage flattening, improbable avoidance of certain mutational hotspots beyond selection explanations. Globally synchronized, silent site biases inconsistent with phylogeny. Not finding them increases confidence. The current layering arose organically. You come back to yourself. Pulse, breath, quiet listening. You are both reader and line being written. Awareness adds a subtle new layer metanotation about how you might choose future edits collectively. The question shifts from are there secret messages to what message are we leaving in the hereditary substrativersity protected or diversity pruned? The palimpsest invites gentleness. Scrape to hard extinctions. Monocultures thin the background text. Overwrite to aggressively narrow. Breeding stock you reduce potential future resilience. Curate with humility, and the manuscript stays richly legible. Open for new, enlightening edits. You let one last image settle, a strand of DNA glowing faintly like a ribbon in dark water. Faint watermark patterns from primordial vents, bold strokes. From oxygen revolutions, italic viral insertions, penciled epigenetic notes, and a small empty margin, a header waiting careful handwriting. And you wonder, softly, after letters and molecular whispers, what traces drift farther out beyond cells. Beyond air, quiet things circling above that also record an epoch. If genomes preserve layered memory within you, what quiet archives might already orbit overhead? Silent instruments, dusted panels, metallic fossils in cold trajectories. You close your eyes and let darkness soften into a gentle interior dusk. In that hush, you invite shapes that are not certainties, but careful maybes, silhouettes of minds that once solved problems, harvested energy, traced constellations, and then folded back into dust long before your lineage stirred. You are not summoning fantasy. You are rehearsing a scientific posture, holding possibility lightly while measuring evidence. The ones who came before, if they existed, would have shared the same physics, the same chemistry, the same stubborn erosion of traces. You cradle the thought as a quiet question, not a claim. You begin with humility. Deep time is an acid that dissolves almost everything structural. A steel bridge spalls in centuries. A glass building crazes in millennia. Polymers embrittle. Copper patinas, concrete fractures. Plates subduct. Mountains weather, and even whole sediments The biosphere digests organics. Groundwater leaches metals. What remains longest are abstractions encoded into chemistry. Isotope ratios, unusual mineral phases, synthetic molecules that resist breakdown, perturbations in elemental cycles, woven into mineral and ice fabrics rather than freestanding artifacts. You remind yourself that absence of gross objects is not strong evidence of absence of a brief technological bloom. You revisit known abrupt events, carbon isotope excursions, warmth spikes, ocean anoxic intervals, extinction pulses, natural explanations, volcanic, large igneous provinces, methane hydrate release, orbital pacing fit, many features. Still, asking, could intelligent agency have mimicked these? Clarifies expected baselines. You learn to discriminate volcanic mercury from industrial emissions, impact ejecta from combustion spheres, biogenic methane isotopes from engineered gas plumes. Even negative results are fruitful. They refine search criteria, teaching you what does not look artificial. You picture an earlier civilization's energy arc. Perhaps it began with combustion of surface organics, then tapped concentrated fossil carbon, maybe experimented with nuclear fission if all grades and moderation geometries aligned. Each stage leaves a fingerprint. Soot morphologies, PAH, polycyclic aromatic hydrocarbon distributions, light carbon isotopic dips, transuranic residues, daughter desequence. Over millions of years, many signals blur into geological noise, yet some stable daughters or alloy corrosion halos could remain at parts per billion detectable with focused instrumentation, nearly invisible otherwise. You kneel mentally beside a drill core. Under a microscope, a thin clay layer sparkles with spherical particles, some volcanic, some meteoritic, perhaps a few metallic glasses, atypical for known airburst processes. You check composition, nickel, cobalt, tungsten in ratios, suggestive of high-temperature smelting rather than cosmic condensation. Are you seeing artifact or coincidence? You replicate analyses, search lateral extent, model atmospheric transport. Extraordinary interpretation recedes unless converging anomalies reinforce one another. Patience becomes a scientific kindness. You let Arkham remain close. The simplest sufficient cause holds until data demand elaboration. Still, you allow imagination to explore plausible trajectories of rise and disappearance. Ecological overshoot is one. A civilization accelerates nutrient runoff, collapses primary productivity support, triggers erosion, reduces resilience. Climate feedback amplifies stress. Social complexity unwinds. Infrastructure maintenance decays. Material legibility rapidly degrades. Within a few 100,000 years, physical detritus is sifted into sediments, blended with natural grains only. Narrow chemical seems whispering of a fevered epoch, another path, restraint and transition. Suppose a culture recognized planetary boundaries early, pivoted to closed-loop cycles, minimal waste heat, materials designed for rapid reintegration. Its stratigraphic imprint would be even subtler. High sophistication could correlate with lower geochemical loudness. Future detection would paradoxically be harder for the most successful, sustainable predecessors. You sense the mirror this holds to your choices now. Loudness is not inherently virtue. Quiet endurance might be .u. Consider technosignatures beyond geology. Orbital debris in stable cislunar graveyard orbits, Lagrange point relics, or subsurface. Lunar regolith artifacts shielded from weathering might preserve longer than Earth's surface. Radar surveys, laser retroreflectors, spectroscopic glints could, in principle, reveal unexpected alloys. Present searches have not uncovered unambiguous, non-human objects there, yet systematic coverage remains incomplete. Deep ocean plains accumulate slowly. Loxygen abyssal muds can archive delicate particles. You map these niches as candidate memory vaults. You breathe slower, letting possibility not become assertion. The exercise itself has pragmatic benefit. It frames how you will scan exoplanet atmospheres. You will look for paired gases out of expected equilibrium. Unnatural temporal modulation of reflective spectra, industrial halocarbons, narrowband lasers, or Leverian's climate stability inconsistent with stochastic forcing. Each detection or non-detection will refine Fermi's paradox contours. Maybe civilizations are brief, or quiet, or geochemically camouflaged. Memory is fragile. Redundancy preserves it. If an earlier intelligence sought to communicate forward, it might encode resilient mathematical motifs into multiple substrates, isotope patterning, prime-numbered layer spacing of inert materials in a borehole, sequence-coded repeats in a harmless bacteriophage widely distributed. Evolution, diffusion, or metamorphism could still erase design unless redundancy overcame attrition. The absence of obvious mathematical paleosignatures does not rule out more subtle, still unexamined strategies. You widen perspective. Perhaps the ones who came before are not terrestrial at all, but microbial extremophiles from early Mars, transferred by impact ejecta, seeding metabolic strategies Earth later refined. In that framing, before is not technological but biochemical lineage donation. The palimpsest idea broadens. Inventions can arrive multiple times, transferred horizontally between worlds via lith. You stand inside a planetary networked experiment, not an isolated test. You turn inward to ethical resonance. Meditating on vanished potentials instills urgency to steward existing complexity. Biodiversity becomes a living archive of chemical solutions. Cultural diversity, a repository of adaptive strategies. Linguistic nuance, a map of conceptual possibilities. Extinction biological or cultural permanently deletes lines future problem solvers might need. You feel responsibility not as burden but as quiet custodianship for unknown successors. Imagine a far future researcher, perhaps not human, holding one of your era's ice cores, measuring microplastic shapes, lead histories, nitrate pulses, comparing them to their own baseline stabilized ages prior. They will construct narratives of inflection, choices made or avoided. Your present becomes their slender inference window. Awareness of being observed across time can cultivate gentler design now, choosing materials that degrade into benign monomers, power systems aligned with ambient fluxes, circular resource loops. You acknowledge risk of romanticizing predecessors. A caution: projecting advanced wisdom backward can excuse present inaction others failed. Inevitability absolves. Instead you pivot. If collapse has been common among hypothetical prior experiments, learning pathways toward resilience becomes more urgent. Conversely, if silence partly reflects quiet successor, sustainable class 5 plateau leaving minimal anomalies, you are challenged to adopt subtlety early. You settle on a balanced mantra: hold wonder, demand evidence, act responsibly, irrespective of unresolved absence. This stance honors both skepticism and imagination. Science progresses through disciplined curiosity. Sleep approaches through released urgency. You accept that the ones who came before may be stories you are writing to motivate careful planetary listening, and that is still useful, because the listening methods remain valid, even if the story's characters never walked. Now you feel night deepen. The planet turns, carrying dust that once was trilobite shell, volcanic ash, comet, ice, meteoritic nickel, leaf vein, ancestor bone. The crust you stand on is a cathedral of recombined fragments. In such a temple, humility is natural. You belong to a relay, not an endpoint. You let one final image form, a faint, thin band in a far future stratigraphic column, multicolored underfluorescence carbon isotope dip, rare earth kink, polymer ghosts, microloy grains, followed by a long stable section of balanced signals, a marginal note, transitional pulse, sustained equilibrium achieved thereafter. You hope the note is real. You do not know. Not knowing keeps attention bright, yet gentle. And as you drift, another question, softer than the rest, if lost minds once shaped gradients and let them go, what delicate markers are you choosing? Tonight consumption, restoration, silence that will tint the thin horizon bearing your layer. You pause over the deep ocean floor again. Pellets of biogenic ooze settle millimeter by millimeter, entombing tiny spheres, some volcanic glass, some industrial fly ash from your era still descending, some biopolymer fragments that will hide below the carbonate compensation depth. Dissolution erases shells. Above, preservation holds. If a prior pulse concentrated novel, compounds insoluble under abyssal chemistry, they could persist as dilute anomalies, detectable only with ultrasensitive mass spectrometry. You picture a chromatogram centuries hence, a modest extra peak inviting. A fresh round of cautious hypotheses. Subglacial lakes beneath Antarctic ice fascinate you. Stable, cold, isolated for hundreds of thousands, even millions of years. They might archive suspended particulates with minimal biotubation. Drilling them demands sterile technique to avoid forward contamination. Each pristine environment is both a window and a mirror of responsibility. A careless probe clouds the record. A careful one extends the planetary memory you can consult. You contemplate mineral genomes, layered growth bands in speleothems, corals, tree rings, seasonal, even event-scale lines, encoding temperature, rainfall, chemistry. These slow scribes average noise and reveal subtle anomalies. Chlorine spikes, sulfur anomalies, lead declines after regulation, Radiocarbon pulses from mid-20th century weapons tests. No earlier comparable radiocarbon spike appeared with uniqueness of that technological behavior so far. The clean baseline preceding your layer underscores how legible a singular pulse becomes. Suppose a predecessor pursued a mostly oceanic civilization, floating habitats, minimizing terrestrial footprint, materials selected for rapid biodegradation at end of life. Their geologic signal would shrink further. Only purposeful beacons, deep buried, inert markers with encoded mathematics would amplify detectability. You have found none. You have not conclusively excluded their absence. The space of possibilities remains large. The space of plausibilities narrows with each survey. Ethics seeps again into vision. Your speculation is not escapism. It is a rehearsal for reading faint exoplanet data where ground truth will never be tactile. Training on Earth's palimpsest increases interpretive literacy. The discipline you cultivate here travels outward, converts guesswork into priors into tests. You return gently to your breathing and let images dissolve into a single felt thread. Continuity of experimentation by matter to know itself. Whether or not predecessors sculpted gradients intentionally, molecules have been exploring configuration space for billions of years. You are a recent fold in that exploration, capable now of returning kindness to the processes that formed you. So you rest inside a calm resolve. Leave enough legible kindness that any future reader, human, divergent, descendant, or entirely new, intelligence will recognize an ethic woven through the thin layer named after you, and still, a further wondering glimmers, beyond stone, gene, and lost machine. Could memory ride light itself, whispered by faint, repeating signals, waiting above the atmosphere for an attentive ear, aligned at just the right time? Perhaps that is where you next turn your gaze upward, past weather and auroras, to the quiet persistence of orbiting artifacts and patterned botons, still looping patiently, awaiting your unhurried attention. If the ground yields only cautious maybes, perhaps the sky holds quieter archives, thin metallic fossils, long-lived orbits, patient beams, inviting you to listen without haste for their slow testimony. You return to the surface. Night holds you like warm, dark water. A mild wind grazes your face, and distant leaves pattern the air with soft, frictional whispers. Above, stars scatter information. Below, soil stores memory. You stand between outward radiation and inward burial, a breathing hinge in Earth's ongoing autobiography. You have traveled through strata, through isotopes, through conjectured civilizations, through genomic palimpsests, through planetary thermodynamics. Now you arrive here, present tense, present pulse. This chapter is homecoming and inventory. What, truly, do you leave? What persists? What dissolves? The questions themselves become part of the legacy, because attention directs stewardship. You start with immediate breath. The carbon dioxide you exhale tonight mingles into boundary layer turbulence, rises, diffuses, is measured by instruments, is assimilated by leaves tomorrow, re-respired next week, dissolved into a raindrop, transported to a stream, or precipitated as a tiny carbonate crystal inside future sediment. Each molecule follows vast statistical branching, yet ensemble behavior is law-like. Your respiratory signal is thin, but aggregated with billions. It shifts isotopic ratios, applying a light pencil tint to the planetary carbon ledger. Your body's elements already journey. Calcium from ancient plankton skeletons inhabits your bones. Iron forged in a supernova pulses in hemoglobin each time you inhale. Phosphorus mined from marine sediment deposits flows through neural signaling. You are a mobile, temporary miner, refiner, and eventual donor back to diffuse pools. When you dissolve, those atoms disperse, rejoin cycles, perhaps gather again into corals, feathers, or instruments. Consider materials you accelerate into the future. Plastics, if uncollected, fragment into micro and nanoparticles. Some sink encased in marine snow to abyssal mud, beyond energetic benthic scavenging. There they may persist, physical glyphs of polymerization capacity, perhaps oxidatively scarred, but still structurally identifiable under spectroscopy. Aluminum rare, in native metallic form before smelting now coats skylines, aircraft, beverage cans. Its oxide passivation grants persistence, unless remelted cementitious minerals from demolished concrete will weather into blended silicate grains, losing form but retaining anomalous mineralogical proportions. Steel returns to oxide, glass devitrifies, yet specialized alloys and ceramics may outlast facades, embedded as accidental technofossils. Information is another strata. Books decay, magnetic tapes demagnetize, optical discs delaminate, yet redundancy extends lifespan. Cloud servers mirror, archives remote, replicate, error-correcting codes, reconstitute bit streams. Still, absent continuous energy budgets and maintenance culture, digital dark ages can arrive swiftly. Stone engravings may outlast server farms. Clay tablets endured precisely because they were abandoned and baked accidental. Paradox, caring. Custodianship maximizes short and mid-term accessibility. Benign neglect sometimes maximizes ultra-long survival. You weigh formats like seeds, suited to differing climatic futures. You think of language. Idioms, metaphors, syntactic rhythms modulate cognition. Most will vanish, leaving faint residue in loanwords or etymological fossils. Yet conceptual frameworks like systems thinking, planetary boundaries, ecological feedback may root deeply, altering how future minds approach decision webs. Memes that align with physical truths persist by usefulness, not by romantic flourish. Accuracy is cultural antifreeze. Diversity, biological and cultural, is a resilient gift. When you protect a watershed, you preserve microclimates, refugia. For species adapting under shifting baselines, genetic variation enters the future as a library of latent responses to unknown stressors. Each extinction is a burned volume. Each preserved lineage is a latent algorithm. Similarly, safeguarding minority languages, traditional ecological knowledge, and local agronomic landraces maintains option space. Legacy measured not in monuments, but in preserved adaptive capacity, energy infrastructure imprints, fossil eras. Carve emission bulges, nuclear leaves, engineered isotopes, and vitrified waste glass. Renewables rearrange landscape albedo patterns with panels and turbines. Dams trap sediment, flatten flood pulses, create stratified reservoirs whose cores capture a dated transition from free-flowing to regulated river regimes. Future cores will show abrupt changes in grain size distributions, pollen assemblages, replaced by cultivars surges, charcoal reduction if combustion yields decline. Transition to distributed, low waste power could manifest as a tapering of soot, nitrogen oxides, and mercury anomalies. Even if technological culture attains a balanced Class V state, a thin early layer of overshoot remains a cautionary preface. That layer's thickness might be centimeters. Its didactic weight, vast. It contains plastics, fly ash, spherules, nitrates, transuranic trace residues, pesticidal molecules, soot. Above it, an ideally smoother chemistry, stabilized carbon, restored. Biodiversity signals. The contrast itself becomes ethical punctuation. Here, imbalance peaked. Here, restraint matured. The sharper the contrast you engineer now, the clearer the lesson transmitted. Personal acts feel small. Scaling logic amplifies. Composting a kilogram of organic waste seems trivial. Scaled across cities, it diverts methane-generating anaerobic. Landfill pockets, alters atmospheric forcing. Planting a tree is a private moment. Aggregated urban canopy raises evaporative cooling, reduces heat islands, cuts energy demand, indirectly lowering emissions, a chain reaction of moderated gradients. Behavioral cascades are legacy multipliers. What of silence? Radio leakage diffusers. Into space, redshifting, weakening. Early broadcast decades propagate as an expanding spherical shell thinner each year relative to cosmic noise. Highly directional communications replace broad, making planetary chatter externally fainter. A mature stewardship may value low-noise operation, voluntary spectral modesty, focusing on fiber optics and tight beams. Extraterrestrial observers might detect a rise and decline of radio, brightness and archaeological light curve of technological adolescence. Ethics of waste become stratigraphy. Designing materials for disassembly, adopting extended producer responsibility. Implementing circular metabolics diminishes future orphan plastics and toxic leachates. Legislation itself, when it shifts practice, broadly translates into geochemistry. A ban on leaded gasoline created a clean falling curve in ice cores and lake sediments. Law inscribed itself into layers as a downward slope. Policy decisions are thus mineralizable moral decisions. You reflect on emotional legacy. Anxiety or gratitude all shape choices. Or expands temporal horizon, correlating with pro-environmental behavior, cultivating it through education. Night sky access, nature immersion indirectly reduces future layer damage. Emotional ecology, the patterns of feeling fostered culturally feeds into physical outcomes. Soft variables harden into rock via mediated behaviors. Measurement is love, enacted as precision. Investing in monitoring networks, buoys, flux towers, seismometers, biodiversity surveys creates dense baselines enabling early detection of drift. Without records, course correction lags. With records, gentle adjustments mitigate large interventions. Later, data continuity is an invisible bequest. Future analysts can parse long arcs. Instead of guessing at truncated series, you examine food systems. Monocultures simplify pollen records. Diversified agroforestry paints complex grainscape signals. Soil organic carbon trajectories respond to tillage practices. Mycorrhizal richness either declines or recovers. Black carbon layers from slashimber. Phosphate hotspots from fertilizer accumulation. Antibiotic residues in sediments. Encode agricultural choices. Regenerative methods may leave subtler net export of soil. Improved aggregate stability, macroscopically invisible, yet statistically legible. Climate moderation. Technologies, if employed, risk, leaving ambiguous markers. Stratospheric aerosol. Injection would generate sulfur, isotopic anomalies, optical depth changes. Perhaps a sharp termination signature if ceased abruptly. Enhanced weathering distributes finely ground silicates. potentially altering river chemistry ratios of magnesium, calcium to bicarbonate. Direct air capture mineralization sequesters carbon as stable carbonates, thickening certain depositional microfactors. Judicious transparency becomes part of Lagousian annotation, accompanying intervention so future interpreters avoid misattribution. Spiritual narratives might shift from dominion to reciprocity. That reframing modifies consumption patterns, which modify fluxes, which modifies stratigraphy. Religion, philosophy, art, when they align with biogeochemical limits, become quiet engineers of lower entropy pathways. Cathedrals of stone once directed collective energy into vaults. Now perhaps community solar arrays, seed banks, open source knowledge commons assume equivalent societal focus. Their artifacts dispersed but cumulative. Time capsules have been literal, seeds frozen, messages engraved on golden records, analog, ceramic microetchings. Yet the most pervasive capsule is distributed redundancy. Open scientific repositories, multilingual retention, modular educational curricula. If a shock reduces complexity, robust minimal modules accelerate recomplexification without repeating harmful extraction phases. Designing fallbacks is not pessimism. It is compassionate foresight. You hold the paradox that impermanence grants. Urgency, meaning you will not personally witness far future readers, yet imagining them refines present care. Legacy conscious of anonymity may be purer. Legacy conscious of anonymity may be purer, unlinked to glory, linked to quiet sufficiency. A future absence of regret becomes an intangible artifact you gift forward. Water, archives, signatures, deuterium to hydrogen ratios shift with temperature. Anthropogenic tritium pulses chronostratically date mid-20th century ice horizons. Pharmaceutical metabolites trace urban effluent infiltration into aquifers. Transitioning to green chemistries gradually erases certain peaks, leaving a graceful decay Kvegan. Law and innovation turned into layered slopes. Urban form either locks in high energy demand or evolves adaptive efficiency. Street orientation influencing albedo and heat retention. Green roofs modulating localized humidity. Permeable pavements altering sediment runoff patterns. Each micro-design scales into catchment hydrology modifications. The Anthropocene is not monolithic. There are microanthropocenes, local patterns of divergence, some restorative, some restorative. Mosaic analysis will let future scholars differentiate them. So you ask, intimately, what can you leave that fosters option space? Curiosity without cynicism, data with context, infrastructure with flexibility, seeds of species suited to future climates while preserving wild genotypes. Cultural narratives celebrating sufficiency, mentorship that transmits patience, not just acceleration, all intangible, yet all convertible into measurable differences in deforestation rates, emission trajectories, extinction probabilities. As night deepens, you picture the planet 500,000 years hence. Much has subducted. Ice age pulses have come and gone. Orbital parameters have shifted insulation patterns. Your thin layer is compressed but analyzable. A researcher isolates it, smiles at clear cautionary transients, sharply bounded by stabilization proxies. Perhaps they whisper gratitude for an unknown generation that pivoted early, sparing them from a thicker, more chaotic horizon of degradation. You sense simultaneously the possibility of a different smile rye, melancholic advents of missed chances. This dual vision motivates tender diligence now. Legacy is probabilistic weighting of those two future smiles. You inhale, Exhale, and let the catalogue condense. Atoms passed along carefully, cycles kept wide and breathing, diversity sheltered, waste redesigned for reintegration, energy sourced within daily solar budgets, data stewarded, narratives oriented toward reciprocity, humility maintained, curiosity sustained. What you leave will never be perfect. Perfection is static. Life thrives on dynamic adaptation. Aim instead for repairable, learnable, forgiving systems, those that fail softly and signal early. Embedding that property is a gift more durable than monumentality. A quiet resolve settles. To belong is to contribute gentle continuity. You are already an ancestor, even now. The stratigraphic pen is in your collective hands this hour. Strokes laid tonight cannot be fully erased. This is not burden. It is invitation to write a compassionate gradient into stone, water, and story. And, while you ponder material and chemical traces, another domain persists, subtle and vast. Patterns of collaborative thought that may one evening reach beyond Earth and extend stewardship outward. You turn your gaze upward one more time. Low Earth. Orbit glints with passing satellites, an exoskeleton of intentions. Some will decay within decades, plasma traced and gone. Some graveyard orbits will cradle inert frames for centuries. A tiny fraction, parked at distant libration points, could survive until plate tectonics has rearranged continents unrecognizably. Orbital archaeology will be real. You are already curating its gallery. Even radio-quiet stewardship leaves photonic artifacts, nighttime light emission maps, transient spectral spikes from coordinated experiments, laser pulses used for precision, ranging subtle modulations in reflected broadband albedo as solar erased scale. Future observers, terrestrial or otherwise, could infer ethical evolution from declining light wastage paired with stable prosperity proxies, a radiative efficiency signature of maturity. Think also of mathematics as shared bequest, publishing, transparent proofs, open algorithms for energy optimization, equitable resource allocation, heuristics. These intangible structures outlast hardware, reinstantiate after interruptions, propagate across languages. They are conceptual seed vaults, an elegant thermodynamic accounting framework that internalizes ecological costs, can ripple unnoticed, yet later appear as narrower isotopic excursions and preserved topsoil depths. Equations can harden into habit. Intergenerational justice becomes physical design. You embed retrieval metadata into long-lived archives. Use plain language summaries alongside formal schema. Choose materials resistant to hydrolysis. Avoid proprietary encodings. You design for legibility under reduced complexity scenarios. Resilience is partly readability to partially trained future minds. A kindness now, perhaps invisibly reciprocated then. Finally, you accept that relinquishment is part of legacy. Letting certain exploitative practices end without replacing them with equivalently extractive substitutes prevents layering new harms atop old. Absence can be positive space, unmined refuge, unpolluted aquifer, unlit migratory corridor. Future sediment missing expected contaminants becomes a grateful silence, an eloquent gap shaped by deliberate restraint. So you stand, gently aware. Legacy is not a monument you finish. It is an atmosphere you help clarify, a soil you help enrich, a chorus you help tune, then you release. The night receives your intention, diffuses it among crickets, cooling roofs, tidal breathing estuaries, and faint auroral arcs. You listen, and in listening, you are already leaving something quieter, lighter, kinder. You feel the threshold of rest approach. Questions slow, but one remains softly luminous. How wide might stewardship reach if continuity and care extend? Past air and orbit toward sharing best practices with any other minds you may someday meet. Perhaps your truest residue is cumulative habit. Reflects to ask, to verify, to empathize with distant futures and unseen species before acting. If that reflex fossilizes, encoded in laws, infrastructures, rituals of maintenance, it will keep attenuating harm long after names dissolve. You breathe once more, feeling personal scale and planetary arc superimpose, and you let the chapter loosen its hold with a final wondering. What gentle, intelligent pattern will the next layer choose to extend beyond you? Will it conserve diversity, honor limits, amplify quiet repair, and widen care across time, space, and waters?